Tell me when we're on. Okay, good morning, everybody, and welcome to day 2 of Reassembly. I hope that you all got to come in on time and enjoy some breakfast. And for those of you who are joining us on live stream, you guys missed out on a wonderful made-to-order pancake breakfast. I hope that's incentive for you to come next year. We're going to jump right into our first talk of the day, which is versioning apps and protocol with WikDev with Right. Thank you.
Alrighty. Hey, everybody. I think I know a lot of you guys, but for anyone who doesn't, I'm Philip Monk, WikDev Wisright, and the CTO of the Klon Corporation. And I often give kind of broad, like abstract talks about the state of Urbit in general, whatever I think is most important to the space. But today I'm not really feeling that, or rather what I'm feeling is that the thing we need most is to be more productive, to move faster, to solve the problems that are in front of us. And that means diving into the weeds and talking about specific questions like how to version apps, how to version protocols. Which is, on the one hand, it's a specific question, but on the other hand, it's also something that applies to anyone who writes an app, anyone who works on core, pretty much anyone who writes code for Urbit is going to have to answer some questions about versioning unless they write it perfectly the first time and never have to change anything. So first thing you think of when you hear of versioning in Urbit is probably Kelvin versioning. And in fact, if you Google it, what you'll see is a bunch of results about Kelvin versioning. If you just Google Urbit versioning, then you'll see our reference stuff for Kelvin versioning, you'll see our glossary for Kelvin versioning, you'll see Jared's blog post about Kelvin versioning, you'll even see the Wikipedia page for software versioning in general, where it mentions Urbit as using Kelvin versioning. So that's how closely associated we are with that. And this talk is not about Kelvin versioning, and so I want to get that out of the way, because basically there already is enough content about Kelvin versioning, and it's a distraction sometimes from mechanical versioning, which we don't talk about enough. How do you actually write apps, sort of to handle changes, as opposed to Kelvin versioning, which is a mindset about writing apps to last forever, which is almost the opposite of versioning, which I guess is why it goes down. So I'll start with the basics of versioning, and that a lot of people are probably familiar with, and then go all the way up to secret knowledge that has only really been known to the landscape team so far, and that we've maybe just been implementing very recently. So there's two basic kinds of versioning that I'll be going through. One is what I would call single-threaded versioning, or versioning of a single app or a single agent. And then the second is versioning protocols, where you're talking to another app, or you're talking to the same app on a different ship, or something like that, which, as you can guess, is probably harder. And so we'll start with the first one. We'll start with single-threaded versioning. So let's go through some, the mindset to try to derive the right way to do this kind of thing. So let's say you're building a to-do app. And it's just a list of things to do, and so your state looks like this. It's a list of pat t, list of text. That's all the things you have to do, and everything works well. You ship this app, everything is fine. And then you decide you need another feature, because to-do apps always need another feature. You gotta be careful, because if you go too far that way, you end up at Asana, but as long as it's hypothetical, I think we'll be okay. So we add a category to each item. We say, it's not just a list of text, it's a list of a pair of the category and text. And so you try this out, you boot up a fake Zod, you install this onto it, it works, everything's great, you're about to try and ship it, but there's just one problem, which is you already have users, you already use this app yourself, and if you change the state like this, it's going to crash, because it's going to try to load in your old state, which had a different form, into your new state, and it doesn't know how to convert that. What category should your old to-dos be in if everything has to have a category? And so this suggests that you have to write a function from the old state to the new state. And so you you remember from from learning about apps that there's this function called onload, and you're like, okay, I'm going to try and use that. And so your first attempt could be something like this, where you say, okay, here's the definition of my old state, here's the definition of my new state, where it has the category as well as the text, and then you have a function that goes from the old state to the new state, where you turn over the list of to-dos and assign them all to the default category. And then you have an onload function that takes in your old state, runs the converter, saves it to your new state, and it's done. And this works great, right? It doesn't crash. It keeps your old to-dos around, and you're like, okay, this looks good, I'm gonna ship that. And this will work the first time that you run it. But the next time that you push another update, or if the system updates, or if someone suspends and revives your desk, or any other way that you try to reload this app, it's gonna break. And that's because you only handle the case where you're upgrading from the old state to the new state. What if it already has the new state? This code is not gonna handle that. There's nothing there for that. And so what we need to do, kind of obviously, is that, well, we need to recognize whether it had the old state or the new state and only run the migration if it was at the old state. And so whenever you hear the word or, that usually means you need a bucksen, you need a union. And so that leads us to this code sample, which is the first one that you should actually run, or that you should actually use, is this pattern, where basically, it looks very similar to the previous one, but everything's tightened up a bit. So instead of old state, we have state 0, which is still a list of pat_t, but we have a version tag where we say this is at version 0. State 1 is the same as the new state on the previous slide, but it's got a version tag of number 1. And that lets us make state any, which is a bucksen, if you're familiar with those, a union of those two types, where we can say, this type matches any of the types that we've ever used for this app. And then you have your conversion function, where you go from version 0 to version 1. Looks just the same as the old one, assigns everything to the default category. Only difference is you also update the version number to version 1. And then your onload looks slightly different. Instead of unconditionally calling the version function, you use this tis_what line to say, if it was at version 0, then call the conversion function. Otherwise, don't do anything, and then save it to your state. And this actually does work, and this is how most apps you see version themselves. And that that should work. If it's at version 1 already, it won't do anything. If it's loading from version 0, it'll upgrade it. You can probably guess how to extend it, which is basically you duplicate everything that's highlighted here. You have state 0, state 1. You also add a state 2, 3, 4. Put that also into your union, into your bucksen. Write conversion functions, state 0 to 1, and then 1 to 2, 2 to 3. You don't have to do like 0 to 3, because you can just chain them together. And then in onload, you do a whole sequence of tis_whats, where you say, if it was at 0, go to 1. If it was at 1, go to 2. If it's at 2, go to 3. And you do them in order because it's possible that you're upgrading several steps at once. Someone may have been offline for a while or had your app suspended for a while. So they might be going from version 1 all the way to version 5. But if you use this pattern, then it'll just do it one after the other in one go. And that works. And this pattern should be familiar to some people because we use it just about everywhere, and it has worked well for us. There's, of course, a bunch of variations on this. One of the most common ones is if you forgot to put a tag on your first version, then you're going to have to find some ad hoc way to recognize the first version. Because if you have a tag, you can use this line of, test whether it was at version 0 or test whether it was at version 1. If you don't have that, then you have to try to distinguish what was there before from what's there now. And that can be difficult depending on what your type was. Like in this case, a list of pat_t, it look like a list of pat_t can look a lot like the first item is a version tag, and so you end up having to find heuristics or some complicated code to figure it out. So the lesson from that is whenever you're writing an app, put a version tag on your state. because you're always going to want it if you ever make a change to it. And it doesn't, it costs 24 bytes. Don't worry about it. Another variation is that, so a lot of variations are cosmetic. It's pretty common to say, I actually want to take all these old states and the old types and stuff and maybe the conversion functions and put them in a separate library. So I keep that out of the main part of my of my app. That's a pretty reasonable thing to do, especially when it starts to get big. But another variation is that sometimes when you do an upgrade, you need to not only change your state, but you need to adjust something about your pending I/O, right? Maybe you have a subscription that you need to cancel or a subscription that you need to create, or you need to start a timer, or you need to cancel a timer, or you need to do something, some kind of I/O as part of this upgrade so that you're in the state that you expect to be. And this is the way that we've done that most of the time up until now, where everything looks the same except you're on load, where you say, you load it in, you load in your union, and then instead of the tiswhats, you have the conversion functions produce not only a new state, but also new moves. And you accumulate them in moves 1, moves 2, and you append them all together and return them all at the end. And this is pretty fragile, and it's been really annoying to deal with this kind of stuff. And I would go so far as to say that this pattern is dangerous because what happens is the upgrading noun to noun is pretty safe, pretty stable, but the moves that you emit at each step are moves that are happening in the present. And that means whenever things change, like for example, some other app that you're talking to, they change what subscriptions they accept. You don't just write a conversion function that you add onto the end of this and don't have to worry about it. You have to go back and look at all the different moves that are produced by all your earlier conversion functions and see, do they emit moves that don't make any sense anymore? And so you have to review all your upgrades and potentially change them every time you make a significant upgrade. And that's the kind of thing that we really try to avoid with version upgrades, is making it so that every change you have to review all your previous changes. That's, there's the asymptotics on that are bad, basically. It makes changing anything get harder and harder over time, which you really, really want to avoid. In practice, we've used this pattern a lot, and it has been very fragile because even if you do go through the trouble of looking at those old moves, now you've changed that code from before, and you really should be testing it. So not only do you have to write code from back then, you have to say, okay, I'm upgrading from 11 to 12, but I also have to test the upgrade from 10 to 12, and from 9 to 12, and from 8 to 12, because someone might be doing all of those at the same time, and there's code there that hasn't been run. And in practice, that's either a lot of work to arrange those situations, booting old pills to try to make this work, especially if they have to go across kelvins, or more likely you just don't test it and then it breaks someone's ship somewhere. And that's the kind of instability that we have accepted for a long time and we can't really accept anymore. So a better pattern is this. Where basically, instead of letting each conversion function produce effects, you say the conversion function can only adjust the noun of the state, right? It's this tiswhat, just like from before when we weren't doing moves. And then at the end of your onload, you run a function that I call inflate IO here that looks at your state and says, okay, let me adjust whatever pending IO I have to match what it needs to be. So it should look at, what subscriptions do you have open and say, okay, I don't need these anymore, so I'm going to cancel them. I do need these, so I'm going to create them. I do need to have this timer set, so I'm going to set that. I do need this clay subscription, so I'm going to open that. And it should do all of that, basically from scratch. No matter what your previous state was, it should look at that and sort of true up your pending IO with what it ought to be. And the advantage of this is that upgrading nouns is pretty easy. So all your conversion functions are all going to stay the same as long as they have enough information that to inflate your I/O. Then there's not going to be a problem there. And then when you add another conversion function, all you have to do is add that conversion function, look at your inflate I/O your inflate I/O function, and see, okay, does this make sense? Did some subscription pattern change? Did some syscall change? Maybe we switched to solid state subscriptions, and a whole bunch of stuff looks very different, but you don't have to go look at your old conversion functions. You only have to update this one function that is idempotent and is just, says, okay, make everything correct. So I will admit that we haven't used precisely this scheme very much yet. It's pretty close to what we do in groups, but not exactly the same. And even the fact that we've been doing something similar to this in groups is pretty recent as well. But I would definitely use this for any new apps, and we're going to try to switch groups over to this pretty soon, because this has become a recent focus for Tlan. A lot of people have probably noticed. Groups can be unstable sometimes, especially around updates. I mean, that's true of a lot of things in Urbit. And so we've been putting a lot of focus in the last couple months into making this stuff more reliable, being able to know just what's happening at every step. And you've probably seen some related stuff like the new connectivity indicators, and all of that's part of the same effort. But all that to say, there may be some details that I don't know yet, because I haven't used this a ton in Anger. So yeah, the summary of the first half is very simple. We went through a long process of deriving it, but the takeaway is always put a version number on your state, upgrade your state from noun to noun, and then at the end run any I/O by looking at your state and looking at your pending I/O, true those up, run anything you need to make it work. And that brings us to the second part of the talk, which is distributed versioning, or versioning protocols, or however you want to say that. Basically, if your app talks to another app, or if your app talks to itself on another ship, then you have a protocol, and it needs a version. Because even if it's the same app, they're going to upgrade at different times. And so you might talk to yourself in the past or in the future, and obviously if it's a different app, they're going to be upgrading definitely at different times. And so you need to somehow handle the fact that you might get requests that you didn't expect. And this is harder than versioning apps regularly, because you don't have control over everything, right? You can't do one atomic upgrade where everything moves to the future. But you can try. And so, so what happens if you don't handle this really and just, see what happens, which is what we've done for a long time, is that you're going to see a lot of crashes, because your apps are going to get stuff they don't expect because it's from some past or future version of themselves or of a different app. And so you're going to see crashes in the dojo, but also the user's not going to understand what's going on. They're just going to see crashes and not know what's happening, and they're probably not going to see anything in the interface. It's just going to be, oh, I can't talk to that person right now, or I'm not getting updates from that group, and I don't know if that's a bug, deep down in the system or all the way up in your app or whatever. And so that's bad. And then the other thing is that there's a lot of ways that unexpected input like that tend to blow up spectacularly. We've seen especially a lot of infinite resubscribe loops, where if you and the host are at different versions, you get something you don't expect, you kill the subscription and recreate it over and over and over until the host is spending all of its effort handling these resubscribes. And in extreme cases, a couple of years ago, we had cases where that would basically freeze the whole network, because everyone's just trying to resubscribe to everyone. So you want to avoid that. And before we look at how to do that, one early choice that we have to make that makes the problem a lot simpler, if we make the right choice at least, is to try to answer the question of what do you do about talking to someone who's at a different version than you? Is there some way that you can support past versions of a protocol, or at least partially support it or something like that? And the problem is that's impossible in the general case to fully support all different versions, even future versions. But there are certainly partial compatibility that should be possible. However, we haven't really used a versioning system or come up with a pattern that is even sort of facially viable, that covers all the bases, even if it has a restricted feature set. And so that's the thing that we should be doing first, and that's what I'm going to propose here. And so one of the ways to make that easier is to say, actually, no, we only talk to people who are speaking the same version as us. And everything else, we want to communicate to the user, we want to handle that as gracefully as possible, but we're not going to keep communicating with someone who's at a different version than us until either we upgrade or they upgrade to the point where we're at the same version. We've worked on this off and on for the last couple of years. We made significant strides in this in 2021, largely due to Liam's work. And then in the last couple months, we've made another significant advancement, and it's so much simpler than the earlier ones that I'm not going to try to derive things as you might think through it from scratch, and instead I'll just describe the way that we're starting to do things now. Although, be careful with this one also, because it isn't exactly what we currently use. We still use a little bit of the old system in groups and landscape. So maybe there's some details I haven't thought through yet, but we're actively moving in this direction. So with all that intro out of the way, we can look at the problem, which can be very specific, even if it's a little bit of a mouthful. Basically, if we were talking to someone who's at the same version as us, and now we have different versions, how can we ensure that when we have the same version again, we're able to continue the conversation in substantially the same state that we left off? Basically, as long as we're talking at the same time, as long as we're talking at the same version, everything should work fine. And if we're at different versions, then there should just be no connectivity really, and it should just kind of pause until we're back at the same version again, which is why it's like a little bit of trying to fake atomicity. And the solution, you describe it that way, is pretty uncomplicated. Basically, ask them what their version number is, keep a subscription open to their version number all the time, and only talk to them when it matches your own. And that's pretty much it. If it doesn't match, you should tell your user, surface to the UI somehow, why they're inaccessible, why you can't talk to them. But that's pretty much it. So to be a little more specific, basically, once you care about a specific peer, right? Maybe you are about to subscribe to them or poke them for the first time, then you want to subscribe to their version number for that protocol that you're using. And this subscription is going to last for as long as we care about that peer. And when we get the response, if that version matches our own, we can communicate with them until either our version number or theirs changes. In either case, when our version numbers cease to match, we need to end all our subscriptions to and from them, stop sending or accepting pokes, and surface to the UI that peer is on a different version that we can't communicate to them right now. And then when the versions match again, either because we reloaded into a new version, or they sent us an update declaring that they're now on our version, then we need to do the reverse. Create appropriate subscriptions to them, whatever that looks like now. Start accepting subscriptions and pokes from them, and surface to the UI that we can communicate with them again. Stop graying it out. And that's basically the system. That's going to ensure that you're always talking to people speaking the same language as us. And that makes things a lot simpler than when you just try to kind of skate by and see what happens and infer from when something crashes, maybe they're a different version or whatever. It's just it's very simple. Ask them what version they're at. Talk to them if you speak the same language. for example, this makes it safe to upgrade marks without changing their name, which is something we've talked about for a long time as we didn't know how to do it. We thought it was impossible because we were like, well, if a mark corresponds to a type and then you upgrade the mark, how do you talk to someone who might be thinking that mark is a different type? And the answer, according to this proposal, is that you're always talking to someone who's at the same version as you, and so they're always going to have the same mark definition as you. And so it's almost like the version doesn't need to go into the mark name or something. It goes into the explicit version negotiation, which is nice. So I'll run through the flow for this specific example of the to-do app, which is going to sound very similar because it's a very generic flow. But so the to-do app we think of as a single player thing initially, but maybe you've added like a manager interface where your manager can add items to your list and they can see your list at any given time. So now it's a distributed app. And it is definitely starting to smell more like Asana. Then once you've done this, now say you need to add another feature to your data model. I don't know, deadlines or something. And so you need to change something about the communication with the other ships. And so you go down the line just like before. When you subscribe to someone else's to-dos, you also subscribe to their version number for the to-do protocol. And then while we're waiting for a response, we record that we're in the middle of version negotiation with that person and display that in the UI. So the user knows immediately why, what's happening. When we get a response, if the version number matches our own, we're going to subscribe to their to-dos and start acting like normal. If it does not match, we record that peer is on a different version than us, and we surface that to the UI. When the versions cease to match because one side or the other has changed versions, we cancel all subscriptions, record that the peer is on a different version, surface that to the UI, and stop accepting requests from the user to interact with that peer. Should gray out those buttons, basically. For example, if you want to try to assign them a task, the interface should tell you that you can't do that because you're at a different version than the host is at. And then when the versions match again, you do the reverse. Recreate whatever subscriptions we need, start talking to them again. And that's true even if the set of subscriptions looks different because you're at a different protocol number now. Maybe your pokes look different, maybe the structure of the subscriptions look different, maybe you switch to solid state subscriptions and it's a whole different interface. But you know that your expectation of that is going to match theirs because they're speaking the same protocol as you. And that's pretty much it, right? It's maybe not the final answer because there's ways we'd like to improve that, but it is a facially viable solution. It's a minimally viable solution where that there's never going to be version-related crashes. If there's a crash, it's a bug. It's not expected. The user's going to understand what's happening at every step, even if they're frustrated that, I can't talk to someone because they're at a different version, which is something that hopefully only lasts for a couple minutes until the update gets out to everybody. But at least they're going to know what's happening, and instead of just being like, well, I don't know, it crashed, and I tried to send someone and nothing happened. One of the reasons this is simpler than previous iterations is because we explicitly track versions, which we've never really done before. What our previous techniques tried to infer from crashes whether we thought they were version-related crashes or not, and that's a mess. It's hard to get that right, and so instead we track that explicitly. And this is a broader point that I've been talking to people about, which is that basically anything you care about you should keep in your state. You should track everything in your state that you care about for any reason, even if it's only to make a nicer UI. We've historically taken pride in not keeping explicit state and instead sort of embedding that in the guarantees of the system. You're like, well, if I do this I/O, I know I'm guaranteed to get a response at some point, and so I'm not even going to keep anything in my state that mentions that I was trying to do that. And this is, I think, basically just a bad idea, and we should avoid that. We should see that as a bad pattern, because it's very difficult to be robust to upgrades of yourself or upgrades of the system or upgrades of your counterparties, because any of that could change without you knowing what's going to happen. Whereas if it's in your own state, when it changes, you're writing the code that needs to migrate that forward, and you know how to do it because you're the developer of that app. Yeah, so if you care about a question, like what version is someone else at, just ask them. Don't try to infer it. If you care about the answer, write that down in your state. It's pretty simple stuff, but we have historically never done it that way. And yeah, one last thing is we probably want to lift this pattern into the kernel somehow at some point. It's unclear exactly how best to do this, and I think it'd be unwise to do that like immediately, because we need to be using this system in Anger for a little while. And hopefully we can improve it to the point where we can maybe handle some partial compatibility and so on. But at some point, yeah, I think we should make this system or a similar system be completely standard across all apps that are talking over the network, which will be a pretty significant change from where we're at now, but I think will be a big step in terms of robustness and stability and so on. And so, yeah, that's the talk. You can really summarize it in about 30 seconds by saying, for an app, tag your state with a version number, upgrade old versions of your state, noun to noun, and then do any necessary I/O as a result of that. And for protocols, just ask everybody what their version is. What is their version, and only talk if you have matching versions. And that's it. That's the only thing to take away from this talk. Yeah, so I think we have time for some questions.
So is there a standard way to version protocols, or is that pretty much ad hoc by your application? And
Yeah.
Second question, too.
So the thing that you want to be careful about there is that one thing that is hard to upgrade is the way that you version things, right? That version subscription, if that needs to last forever, that needs to be really simple, because upgrading that is a bit of a pain. Possible to do, but it leaves some cruft around, basically. In terms of how to version it, it's really just you need to give some kind of identifier, which we've been doing, just incrementing numbers starting from 0. If you're in a context where you're doing Kelvin versioning, you can decrement from there. But it really doesn't matter if you're only looking at matching versions. You just need to give some kind of a tag that identifies what it is.
So it is kind of ad hoc. You just put a version tag somewhere in every protocol transaction.
Yeah. The thing that will need to be that you need to coordinate on is knowing what subscription you should ask for, which is probably going to be at the path something like / protocol name / epic is the word we've been using, EPIC, to mean this is the version subscription. But what it returns, I think right now we technically require it to be an atom, but it really could be any noun. It's just because the only operation we do on it is check and see if it's equal to us, and equality you can do on any noun.
Second question is, so as long as you are using the subcomponent names and not LARC notation for the bool, there's nothing to worry about in bool upgrades from core version to core version?
That is largely true, but it depends on how big an upgrade it is, right? If it just added something to the bool, then it's not going to affect you if you use the name. It'll be at a different axis, but the Hoon code will be the same. So when it gets recompiled against it, it'll be fine. But if it's a more substantial change where one of the things that you refer to maybe just works very differently, like an example that may come up at some point before too long is we keep track of your subscriptions in the bool, and if we get to the point where we want to switch a lot of those to solid state subscriptions, then it may be that that's going to look different in the bool to the point where your code actually does have to change, because it's not a map with the same keys and same values. Maybe it doesn't have the same name, something like that. Yeah.
Is there like an example implementation of this that I could look at just to start an app? I'm pretty new to Hoon. In fact, I haven't really written an app yet. So if I wanted to start from scratch and start from this, is there a place I could start?
So for the first half of it, for versioning an app as opposed to a protocol, yeah. Okay, that's in App School. That's good. Yeah, that you'll find examples in most any app that's been around long enough to have changes like that. For the protocol versioning, the only examples that I know of are within groups, chat, and the related apps there, and I don't really want to point you towards those because they're still a little bit of a mess right now. And they're certainly some of the most complicated apps that there are on the network right now. But it's not a terrible idea to just go look at the onload there and see what how much of it makes sense, because it is pretty close to these patterns, and hopefully before too long we'll be even closer.
Yeah, I had a similar question. So, does groups use solid-state subscriptions for this versioning pattern that you're describing, or is there another pattern for pulling subscription and I/O data into state that you guys have been playing with prior to that?
We do not use solid-state subscriptions yet, but there isn't another pattern we're using. The plan is to use solid-state subscriptions when we get to the point where either we're making significant changes, and so it's, if we're making changes already, you might as well make that switch as well. Or if we get to the point where we need it for performance reasons, where hosts are getting overloaded by these requests, which we're constantly getting closer to, but so far we're just using the system that Liam put in place at the end of last year.
Yeah. So given that you kind of said that this isn't like the ideal end state for versioning, right? And there might be other takes on versioning. Mm-hmm. Why should this go into core?
Well, I'm not really proposing that it go into core at the moment. I'm proposing that. Well, so the most concrete thing that I'm doing is saying basically this is how the landscape team has been doing it and is about to start doing it. Because I think that's useful for other people to know, because we're on some level the only app the app that has been that has changed the most and been used the most by third-party developers. And so there's while we have often done a pretty poor job of this stuff in the past, it's we have learned some stuff from that. And so I want to describe how we're thinking about that, get other people thinking about it for their own apps. Yeah.
Yeah, I think that's cool, telling people about it, but getting into a core is a totally different thing, right? You guys do have experience with this stuff, but it also, as you've mentioned, it has blown up catastrophically multiple times in the past, and people who have been dependent on these versions have bit the bullet because of that. So I really don't think that this is the perfect solution. So I don't think it really kind of has any place in core, personally.
Yeah, I mean, that's what I mentioned at the end is that I wouldn't want to put this in the kernel or somewhere in core at this point, because we need to build up a track record of doing this stuff well. And our track record for that is pretty bad right now, which is why it's come to the front of our attention as being something worth putting effort into. And so this is where we're at with that, yeah.
Cool.
Any other?
Yeah.
Cool.
Any other questions?
Can you say a little bit more about the inflate IO function? I'm not really sure where you'd go and grab what you're interested in, and then where you'd record it and how you'd kind of convert it around.
Yeah, so the idea of the inflate IO function is that any kind of IO that you want to have outstanding, subscriptions or a timer that you care about or something like that, you should record that in your state, and then when you upgrade, you pass that into this inflate IO function. It needs a better name, but and what that should do is to the degree that it can, it should go ask everything. Hey, what IO do I currently have outstanding? For example, it can look in the bowl and see, here's the subscriptions that are coming into me, here's the subscriptions I have out to other people. And it can scroll through that and say, okay, according to my state, I should have these subscriptions open because I'm in these groups or in these channels or something like that. But according to Gall, I have this set of them, and so I can unsubscribe from that one because I don't need it, and I should add a subscription to this because I do need it. One of the bigger limitations there right now is that while we do give you a list of the subscriptions that you have, we don't necessarily tell you, like it is difficult or impossible to tell some of the other outstanding IO you have. Like there's no way to ask Bane, or no practical way to ask Bane whether you have an open timer to them. I guess technically there is a way, but it violates all kinds of permissions, but we don't have a permission system yet. But there's no intended way to be able to ask Bane, do I have a timer open? Or to ask Clay, do I have a subscription to you? Or to ask Jail, do I have a subscription to you? And so, those would be things that I would want to add to core, would just be expose basically what pending IO that I have outstanding, which is something that as an app you should be able to do that regardless of what version system you're using.
Yeah, thank you.
Yeah.
Any other questions? No? All right, let's give it up for Wisdef. That's right, everybody. Fill it up. We're going to take a quick transition as we set up for the next speaker, so everyone has a few minutes to go to the bathroom, grab a drink. We'll be back soon. Alrighty, and we're back. So coming up next, we have a presentation called Building a Better User Space, presented by Lambda Librem of Holium.
All right. So, yeah, I changed the name a little bit, last minute. Sorry, guys. Yeah, so now it's, what I want to talk about is building composable apps, but also crypto apps on Urbit. So it's going to talk a little bit about a few things we're doing. One of them is this data composability agent database called Bedrock, and this crypto identity system that's supposed to make it easier to do like any crypto-related apps on Urbit. And then I'm going to give you a little preview of what we're doing with Realm next. So to start with data composability, I want to explain a little bit about our experiences of building on Urbit so far and trying to build a composable apps. And so to start, I'll kind of walk through this overview of a Web 2 model of integrating different APIs and things. So to start, like, you want to get a balance from a third-party API. I don't know, maybe it's Alchemy and you're trying to get the balance for your ETH wallet or something like that. But usually these things come in their version, right? And I think we just had a talk before this about versioning, so I'm sure that's going to help. But from our experience thus far, really what we've realized is in the Urbit case, it's effectively the same when you're communicating between two agents in that if I want to integrate with the ETH wallet, which is a third-party developer, then I have this dependency I have to manage, right? So if they update a type or they update some state that they're storing, then I have to be aware of that before they push the update, or else my app breaks in different ways. And so we figured this out because we had done all of these bounties at the beginning of the year when we launched the first version of Realm. And we had all these guys building apps on our agents, and we had spaces and all these different things that we wanted them to integrate. And then we were like, we need to update something. So we would do an update, and then all of these apps would break. And we were like, okay, so this is not great. And then we had integrated with groups, and if they push an upgrade to like chat or groups or change something in the way that their types were set up, then our scribes started to break, and different integrations would break, and then we would be confused for a minute and be like, well, what's going on? And then we'd figure it out, and then we'd go and update and stuff. But so right now, like within the ecosystem, this is like fairly early, and it's okay to have these sorts of growing pains. And so what we wanted to do is figure out like, how can we make this easier for developers? And it's not just about like integrating with different apps. It's about discovering the data you can work with, right? So in this example here, this is sort of our solution to this problem, where the third-party dev who writes the ETH wallet would actually integrate with Bedrock, and they would, instead of storing state in their own bespoke structure, they would actually store it in Bedrock. And then my agent would just read that data out of Bedrock, and I can get into a few of these points, but the goal is that we have data that's addressable by unique path. So it's you can scry it, use it for remote scries. And this is an example of it, right? So like I have a table, notes at it, v0. So everything's version. So you can imagine all data types that are stored in Bedrock have a version number with them, right? So if I build against version 0 and they upgrade to a new version of the notes edit table, then I would get, it wouldn't break because version 0 will still work, because part of the system that we're trying to build with Bedrock is the forwards and backward like upgrades, so that data from version 0 can still work, and when it goes to version 1, you can take your time to upgrade if you need to. But this sort of helps when you get to things like, if you want to build an app, like a quick little app that you want people to build on, and then you don't really think about it for a while, and you come back to it, it could just totally have been broken, and you weren't aware of that until like people were messaging you like, hey, the thing I was using is now broken, right? So this hopefully would help solve that problem a little bit. The other thing is that there's this common pattern you do when you're building an agent where it's like, okay, I've got the state I want to send to all these peers, so I'm going to manage a peer list. I'm going to say here, here's how I want to sync that. And every time you build an agent, you effectively have to build a new sort of like way to do this, over and over again. So the thought here is that we'll actually make it all based on paths and have every path have their own peer list, right? And so we have a few strategies for this. Like we have single host, shared host, and gossip. To date, in the current version of Bedrock that's out there, we only have the host version for the replication and syncing strategy, but we're working on the other ones over time. The next point that's really important is versioned. And then the fourth one is automatically syncing to a client database. So this is another thing that we had a challenge with, was more so like, okay, so every time we make a new agent, we have to integrate that with our UI, and there's like a lot of work to be done to like make sure everything's syncing properly and whatnot. So we thought, well, what if we just synced Bedrock itself to a local SQL database so that the UI could just query out whatever data they wanted, and you could join across apps and aggregate things in a view where you don't necessarily need an agent, but like, oh, I want to show a calendar event, with this, I don't know, other thing that's going on, maybe a talk. There's like, I'm listing all of the conference, or I make an agent for Reassembly or something, or like a conference agent, and I want to like reference a calendar event, right? Being able to do that without having to like, go off and scour Urbit and DM people, or like see who the developer of the calendar app is, and be like, hey, can you like walk me through this? Our solution is more so like, you would actually scry Bedrock's type path, and it would return back all of the data types available for you to build on in Bedrock. So that's essentially what the solution is. And so to clarify a little bit, paths, like what are paths and what are the types and what are the tables and what does all this mean, right? So the way that this works is that a path is not a table, but a path is like a pointer to a set of data primitives that would be synced on that path. So in this case, this is a very simple example, and this is actually currently working in the latest version of Realm, where we just totally replaced lexicon. Instead of having it be a bespoke agent, we converted it into Bedrock as like a first test to see how it would work. And effectively, in Bedrock, it's stored as if it's a series of like flat tables. And we're working on having a way to dynamically like display that in a structured type. But for now, it's kind of like a little bit raw. And I've actually was talking with Ted the other day, and he mentioned, what was it, Ulam. Yeah, something that he's working on that could make it a lot easier. So I don't have a lot of details on that, but if you want to know about Ulam, he's the guy to ask. So this is an example of lexicon, right? So you've got your word, you've got a series of definitions, so you might have multiple ones per word, and you've got your sentences, right? So the cool thing with this is that this data just syncs magically to the UI because we've built this JS, lib for Bedrock, and effectively it syncs the entire state from Bedrock to the tables on the client side, right? So then you just, you only have to use this, and pretty much any app that you want to build just would work, in building a simple UI. So supported column types. The way that we built it so far is that you can essentially use any atom for the value, but when it comes to more complex types, we've restricted it for now to be more so like a list is a list of strings, sets a set of strings or T's, and same thing for maps. But outside of that, you can essentially store for every column any type you want. So this is really the core value of building on Bedrock, and it's something that as we migrate pretty much we're migrating all of the things we built on Realm onto Bedrock, and this is going to be the most valuable reason to do that, because now you have all these common types that you can associate with any data element, any row of data. So you can have votes, ratings, comments, tags. We have the concept of following, so you can follow a specific path that someone's hosting. Maybe it's like, I don't know, their meme repository or something like that. So you could follow different paths from different people. And the last one is the most exciting one to me, and I think it's going to be the most powerful thing in Bedrock, which is the ability to retweet any row. And we just call it relaying. So really, the way that it works is like relay objects are they're kind of like C pointers in that the only way, you have to remote scry them to get them dereferenced. And this is like an example going through how it would work, right? So imagine in group chat 1, there's Zod and Bus, and then group 2 has Zod and Fed. Although, I don't know, I don't think I'd relay things to Fed personally, but let's just say Bus wanted to Fed post or something, and he forwards a message from group chat 1 to group chat 2. Effectively, the way it works is that Zod, he creates a relay in group chat 2, pointing to the object in group chat 1, but he also publishes that version, the version of data that was in group chat 1, and hosts it on his own remote scry namespace. So the burden's not on the original poster, the burden's on the person who relays the message. And so Fed sees that the new relay row is in group chat 2, and he goes and calls the rest of his FBI buddies. And he follows the link and pulls the data and sees a meme that's spicy, and then he logs it for his superiors. And so here's a visual example of how that would work. So in this case, this is the original group chat, right? In Bus, there's a message there. And so what happens when Zod wants to relay that to the other path is he publishes in the relay table a reference to the ID. And this is simplified because if we wanted to write all the paths out, it wouldn't fit on the screen. So he puts a reference back to the original path so that here in the group chat 2 path table, we have this as the content type is relay. So what happens here is when you see a relay type, you go up to the relay table and you see, okay, what is the ID? Who has posted this relay? And then you remote scry the original contents. And then what happens to all the peers on group chat 2 is that they'll actually create a path for group chat 1 that just stores that single message. So that way everything is sort of addressable, and there's no weird kind of hacky things in there. So you can actually relay multiple times, multiple people can relay, but because of the way the relay table works, and it's a unique ID, if you have 10 people that relay the same message, you only ever get one copy of it pulled to the other peers. So that's the relaying functionality. And for us, we're using this for forwarded messages, but you could also use it for lexicon, right? So if you're in one group or space and you want to forward it a hilarious word to another one, you just could relay that from one path to another, and it just magically syncs over. So the idea here is not only data composability when you develop, but having data just pass around. And obviously there are permissions, you can restrict shareability of certain paths and things like that, but generally it's cool if you want to build something social to be able to reshare it across paths. And so what's still to come for Bedrock? So everything that I kind of described there is currently out there. We've been tweeting about it a little bit. We have docs up there. We have our Git repo for the agents is now open, so you can go and check it out. But what we're doing now is we're working on the data type scry, because really the goal of this is to make discovering the data primitives easy, right? So we're working on a calendar app right now, and we want people to be able to download the calendar app. They would then be able to scry the type scry, and it would return, here is the data primitives for calendar, which might be the calendar object, it might be the calendar events, might be time zone related things. All of these things are now listed, and you can then, instead of going and writing your own backend for a calendar, you just leverage that, right? And you can write to it and pull from it, and if you wanted to add a calendar event from an app for whatever reason, maybe it's in your group chat you just are hey, let's schedule a meeting. You could just write straight from the group chat app or whatever you're building into the calendar table or type, and then just it would appear on your calendar, right? So that's the goal of this, is so that people can discover the primitives, so you're not just rebuilding them over and over and over again, right? So we're going to do the other replication strategies, which are shared host and gossip. And the last one is the adding a new common type, which is going to be all of our chat data that we have now. We want to make it, Bedrock friendly. So we're going to actually migrate everything from our, bespoke chat agent into Bedrock. So that means that anyone could write, if they want to do a chatbot, if they wanted to write their own features into chat or pull our chats in and then add stuff to it, you'd be able to do that. And hopefully, in doing all of this, we could probably come up with a way we could share maybe some UI code so we can share these cool new features that we add, right? So yeah, if you want to contribute, we are now that the repo is open, we're actually looking for people who would want to work with us, because the goal of this is to get other developers, to help us build it out, use it, so that we can build this more composable, discoverable, data layer. So yeah, the second one is crypto identity primitives. And this is the one that I'm the most excited about. The Bedrock thing is something that we kind of need as a foundational piece to make just our development better, but also to help more coordination amongst different people and players in the ecosystem. But this one is also going to be one of these open primitives that we're going to build into Bedrock. So really what this is all about making the Urbit ID the root identity, and then being able to associate a lot of different addresses, perhaps, and aggregating NFTs underneath a PAT-P, and then obviously having a little social profile on that as well. So what does this look like? This is a design of what we're building currently for mobile, but effectively what you can see here is that I've got my default. This is my default address. So if you want to send me anything, you can look at my profile, see that, tap it, and pop over to Wallet Connect or through Wallet Connect to MetaMask or anything else, and send me something, right? These addresses here effectively are you sign a message stating that Lambda Libran owns this address with the private key from that address. So when you add these addresses, you pop out to MetaMask or Rainbow. It prompts you to sign, and then you sign, and then you can add this to your account. And the thing with Passport is that you can do a lot with that, right? You can start doing things token gating a chat, right? You can token gate chats or any feature that you want to token gate. And this is one thing that we're doing right now to build it out. But the goal for this is that because it's built on Bedrock, because it's more of a more open primitive, anyone could start doing more crypto things on Urbit. Because effectively, what our vision is moving forward, or what we're focused on in the next year probably, is going to be just leaning heavily into the crypto narrative, right? And I'll give you some examples of that in a minute. But yeah, Passport's going to be an open primitive for everyone to build on. Right now, we're still in the process of building it all out, but we're still looking for people that are interested to chime in, to help out, to help put in PRs and ideas. And yeah, so what's next for Realm? Like I was saying, it's all about crypto. And for us, it's about mobile and crypto. So one thing that we're building is crypto login, right? So what does this mean? How do you log in to your Urbit with a wallet address? In this case, we're doing it through our hosting platform. And usually you log in with email and password, but we want to make that more crypto native. And so now you can sign in with Ethereum, and you can actually pay for hosting with Ethereum, or eventually we'll support USDC and things. And yeah, you just connect to the wallet, you sign a message, and then you're logged into chat, right? It's pretty straightforward. And yeah, like I was saying, crypto payments for hosting. So this just allows people that are more crypto native, or people that have a lot of crypto, to actually pay for some actual service with their crypto, right? So I think this is going to be really exciting moving forward. So I guess the last bit of this is We do have a public test flight link for the mobile app. So as we continue to build out these crypto features, if you want, just go to tinyurl/RealmIOS. You can hop on, and you can start playing around with it. So that is like the big overview. And I think there was one more slide, but I don't know where it went. But it just says questions. So if anyone has any questions or, yeah?
I'd never seen the word scry before, so I looked it up. Under scry.cloud, I found scry is using emergent research on cognition and decision making to turn the art of predicting the future into a learnable quantitative discipline. Can you explain it, elaborate on that in your context?
Yes. I don't know. Is that in the docs? I don't know. No, I would say a scry is effectively the way in which Urbit describes a GET request, is the simplest way to put it. Like
Does what?
a GET request, so like when you call an API and get a response, that's sort of what a scry is in the Urbit context.
Okay.
Yeah.
Like a REST HTTP GET request.
Yeah, unrelated to the.
It's a way of reading data.
Yeah. Yeah, reading data.
Okay.
That's it. Anyone else?
Could you guys use a microphone so that we can on the live stream? Thank you.
Where's the microphone?
So will Bedrock values be bound in the scry namespace? How exactly will that work? Will they be referentially transparent? Anything that goes in there? Can we make that decision as a developer?
Currently, currently it's limited. So I would be happy to talk about, making sure we support those things. It currently just effectively is the types that we have set for the column types. That's effectively the response. So it's all based on the types that are baked into Bedrock so far.
Yeah. Let's say someone has an alternative implementation for chat message or follow, right? Are either of those that you guys have already put in Bedrock the de facto implementation for those things? Or how would you kind of find or choose whichever implementation you want?
Yeah, I mean, so the ones that we have there are just kind of like there as defaults. It's ones that we think are useful and that are simple. But if there are other ones that are built into Bedrock, effectively what it would be is you would have to install an app that has, that's implemented that follow primitive. And maybe it's called I don't know, whatever you want to call it. Maybe it's called, your app follow or something like that, whatever the name of your app is. But effectively with the discovery scry, where you can just scry for all the types, you'd be able to see that, okay, there's actually different implementations of follow. And the goal for building out that scry and leveraging the sort of dynamics type system that Ted has been working on, I think the goal is that you could actually see exactly what those different types do, how they're structured, and you can make the decision of what do you want to use, right? So it's not exclusive to just those common types. It's just we wanted to put something out there to start, making these sorts of features work on Urbit, right? So if you have a better implementation or a more robust implementation, maybe we could make a new version of the follow and leverage the more advanced version that is more useful. So we'd be open to doing that as well.
Yeah, we're actually working on a versioning system for types and whatnot. So it would be good to talk about that. Yeah.
Oh, for sure. Yeah.
So I think for Realm, you guys thought about putting in the client this MySQL database to pull from. Have you thought about putting an Urbit Moon into the Realm client and having that be what you're kind of accessing more locally from the client side?
I mean, it's something that I think in conversations we brought up, or some people have thrown the idea at us, but we haven't explored it really yet. But that could be an alternative. I think it'd be more interesting to, maybe just having it be a background service on your computer that any app could read from that is leveraging your Urbit data.
Any other questions? No? Let's give it up for Londa Vibrant, everybody.
Cool.
Amazing. Thank you so much. So we're gonna take a break for lunch now. Lunch tonight is pulled pork sandwiches, so help yourself. The pork is made, smoked by the caterers themselves, so it's apparently very delicious. Do try to come back at 1:15, which is 15 minutes a little earlier than normal because we do have a special demo on Area. So be sure, sorry, Era, sorry. So be sure to come back for that. Thank you, everybody.
couple presenters that will conference, right?
I think so. Yeah. Awesome. Well, thanks everybody for coming, wrapping up your lunch, and coming to see what we have to offer. We're a little last-minute edition. We want to do a quick demo of what the Quartus team has been up to for the last few months, basically since the Volcano Summit. I'm Sarlev Sarsen. This is Litneb Maltype, and we're here to talk about a new era for trust. If my slides want to go that way, I guess. Maybe you can. So, why are we in Wyoming? Like, Cheyenne's kind of hard to get to. We've heard a lot of people talk about community. Balaji at Assembly last year said Urbit's killer app is community. But I think there's a more specific reason to why the community is great. And it's basically that Urbit brings trust to the network age. This is why a bunch of us went to a random volcano in El Salvador without much guidance. We're like, oh yeah, this is going to work out, I'm sure. Going to recently reformed, violent South American country is safe. And this is really important, but it's something that as the Urbit network grows, kind of well beyond the Dunbar number, it starts to pass the threshold of a large tribe. I think we maybe have 4,000 or 5,000 ships on the network now. The size and shape of the network is surpassing what we can do for discovery, filtering, and curation just in our own minds. So we want to build some tools, some underlying protocols that make it so that you can expand beyond what your brain can hold. One of the great ways to think about this, in contrast to Web 2, is if ownership means if ownership of your money means holding your keys, ownership of your relationships means holding your social graph. So we've been building Era for the last few months, and now are ready to release just a little proof of concept prototype called Monera, because it's the small version, which you can actually go, and I would encourage you to go download it right now from distro Dazza Dalton, and you can follow along and check out some of the stuff if you like. With that, I'll kind of hand over to Litneb to kind of talk a little bit about the thought process behind Monera and some of the design decisions that were made.
Cool. All right, so yeah, I definitely would encourage you to go to distro Dazza Dalton, download this, because a portion of this is in constructing some of this reputation for individual ships is marking somebody as real. And since we're all here and we can look each other in the eyes and know that one another is real, then I would encourage you to do that on the app. But Monera started, maybe in the last few months or so as a grant, and we've been in the research phase of the grant. This first iteration of it, and I think we're pulling up a demo here, or you got it. So the first iteration of the grant, if you want to scroll up to the top, is basically 3 agents, and they're super simple agents, but they represent 3 different, types of primitives that we want people to build using this Monera protocol. The first one is basically a listener agent, and if you look up here at the very top, we have basically a place to input a ship. When you put your ship in there, you're going to be deriving a reputational score, and underneath it is a list of the different ships that you've plugged in there, and a few different categories of the scores that are derived. So we have, on the far right, you can see some reacts, just a thumbs up and a thumbs down, and that's an example of a listener agent that we have for Monera that scours all your chats through all the neighbors with which you're deriving the score from to see how many people are liking your posts and how many people are disliking them. The second example that we have of a primitive agent for the reputation protocol is like an active input agent, and that's next to it you can see just the word real. And at the bottom of this Monera app, you can actually put in a ship, and you can say, is this person real or is this person fake? When you poll all of your pals, or eventually the neighbors whom you decide, it doesn't have to be your pals, you can create a score derived from all of their inputs. Is this person real? Is this person fake? The last agent that we have on there, if you want to scroll to the top, the last one that we have up there is we just call score, and this is the example of an aggregator agent. So we take the score from the first one, which we call alpha, the second one, which we call beer, and we apply a little math to it, and then we create a score. So the idea is that after aggregating multiple versions of these reputational agents, you can have kind of a contextual score on somebody's reputation. If we go a little bit below, you can see this list of neighbors. It pre-populates with all of your pals, but the idea in the future, moving forward, we could say, hey, what does the entire group of Hooniversity, what do they think about Sarlev's ability to write good Hoon? Right, so we want to have multiple ways to change the inputs from who we're polling, and then obviously change who it is that we're applying the score to. But I would encourage you to download it and start, seeding the network with some of these reputational scores so people who didn't make it here can start seeing who was real, who was not.
Yeah. So, obviously this is just sort of the smallest little proof of concept of these ideas, but you could certainly imagine the stuff that could get built on top of this. Personalized ratings, I don't know how often people go to Google and they're like, this was a 5-star rating, and I went to that restaurant and it sucked because I don't like spicy food, or name the thing. But you could start saying, hey, I'm getting ratings on these things based on not what the world says about this thing, but that the people that I trust about a certain topic are saying about it. You could do things cross-platform. So now you're starting to get, someone's Uber, driver rating can start to influence the way that you're thinking about, how they talk about car recommendations. So it starts to be much more interesting across a variety of use cases. You can think about this on sort of the open source software, let's call it monetization problem, where what are you going to do if someone's just always stealing or can just copy your code and run it themselves? Well, like as Hard and Hardest says, a certain level of piracy is actually desirable, but it's just another mechanism for price discrimination. And if maybe you want to hang out with people that are always pirating their software, so that's a network you go into. But maybe you also want to be hanging out with people who are funding the developers that are building the cool shit. And if you see across their reputation score that they're kind of always stealing software, you give them a little bit of a cold shoulder the next time they want to hang out. Of course, we're building this for everybody on Urbit and kind of building it in public. Like Taylor said, this is kind of milestone 1 of a 5-milestone project. We've been meeting in the Urbit Hacker House Gather Town every week, 9 a.m. Pacific time. We'd love to kind of have people come in and start to think about how they want to use some of this functionality in their apps, because we're about to hit the stage where now we're going to build the Era agent and sort of the underlying API and interface for that. So we want to see what inputs and other thoughts that people have to integrate. We also are getting funded by the public. So we have currently raised about $40,000 in just donations, pledges from the community, various Galaxy owners, the Urbit Foundation, and we are using another lovely Quartus Technology Fund to solicit those funds. So if you go to the Era desk, you'll see that there's a funding campaign there, and you can make a pledge, say, hey, I want to contribute to this. Those funds get controlled by the Dalton collective escrow team, and then are only released once milestones are met and satisfied to the escrow team's satisfaction. So come hang out, tell us what you want to see, help us build it, help us fund it, and download it and make sure that you know that the people that you're talking to on the internet are real. I guess, yeah, questions? Anyone have questions for us? Yes. Oh, yeah, you need a microphone, I suppose.
So will this replace I actually met Minderfold and Gora that I send to people that I meet in real space?
It doesn't need to replace it, but it could augment it. You could imagine a world where perhaps you have if this then that style agent running on your ship, where you give someone a beer rating and then it just automatically issues them Agora. Like, that would be awesome. Easy, fun, lovely.
Nice.
And then there's definitely a shout out to the dev team that couldn't make it here. They're stuck on the East Coast and stuff. But Normal Postum and LitLeb Nibite are the great minds behind the app, and we're just the front men. Yes.
I kind of changed my mind about the question. I was going to ask if there are disagreements in the network, like if some of my friends say something's good and others say it's bad, what happens there?
Vinny was a plant.
Just a little bit.
And so one of the important parts about this is a subjective reputation graph. So your view of the graph is what you think it is and what you want it to be. A great example of this in Monera that we've had lots of internal debates on is like what makes someone real. It's the agent's called beer because it's like I can have a beer with them. You'll see I put Zod. I gave the Zod a fake because Zod isn't really a person. But you could say, I know that Mark's always running Zod, so like I'm gonna give it the thumbs up. Like this is all subjective to you, and you can kind of just get a consensus around people, or you could say we disagree, and that's okay too.
Any other questions? No? Let's give it up.
Awesome. Thanks, everybody.
Well, thank you guys. We're going to take a quick break as we prepare for the next speaker. Thank you. So yeah, we'll be back in a few minutes. Let's get you mic'd up.
because he's on that frequency.
I know. Welcome back, everybody. We are now going to continue on our program with a presentation called Names, Data, and Networking, presented by Master Morzad of the Urbit Foundation. Give it up, everybody.
Thank you all. Thanks to Mr. Todteg and Tacen. This event has been fantastic. Very happy to be here. So I've been working at the Urbit Foundation for the past handful of months. Prior to that, I was at Tlon for a few years. And we have been focusing a lot on the Urbit network. Myself, Robnus Rickford, Norsa Torin. Really a simple and straightforward set of goals that we want to accomplish here. There's a lot of great things about Urbit's network. But outside of maybe the first one, it's not exactly famed for either of these properties. And networking's hard to talk about. It's really a strange thing. It's quite different from computation, and you construct functionality from a very disparate set of, I don't know, probabilistic behaviors, right? Fundamentally, it's insecure, it's unreliable. You're just sort of shouting into the void. And talking about how to wrangle it is bringing together many, many different pieces and then kind of squinting through the overlap. And so I wanted to start at the beginning and try to recap what we're trying to accomplish with the Urbit network, examine some of the other sources of inspiration that we'll go into in a fair bit of detail, some of the history of networking itself, and then take stock to see if we are accomplishing what we're setting out to and if we're getting what we're paying for, because we're paying quite a bit. So of course, you can't talk about fundamental Urbit technology without going back to Urbit's original public introduction to the world. It's all here in this post. And I'll just go ahead and read the quote. I call the Martian network architecture source-independent networking, or SIN. In almost every way, a source-independent network is exactly the same as today's insecure, unreliable packet network. However, there is one difference. To make IP source-independent, remove one 4-byte field, the packet source address. Now, to be completely honest, I have puzzled over these lines for years, because if you take a look at an AIMS packet, not only does it not remove the 4-byte IP source field, it adds an up to 16-byte Urbit source field. And so what's being said here is subtle and not particularly clear, possibly aspirational. One more bit to quote. Strangely enough, some insight into Martian networking can be gleaned by reading this Wikipedia page, content-centric networking, or watching this Van Jacobson talk, a new way to look at networking. VJ, in case, oh goodness, there are different slides. I will get that into my head shortly here. VJ, in case you're not aware, is a god in human form. When I saw the latter, I thought, that bastard had my idea. Bastard was not actually the word. It was a worse word, illegal, in fact, in many states. But of course, any truly Martian idea is far too simple to be original. Fortunately, VJ did not have my whole idea, just the network part. And as you will see, this quote, while hilarious, is actually harder to interpret than the previous one because we'll talk about what content-centric networking is, and then we'll talk about what aims are. And the degree of overlap is technically present, but incredibly remote. So I will try as quickly as I can to recap this video. This was a talk that Van Jacobson gave at Google in 2006. Van Jacobson is most famous for writing traceroute and basically making TCP scale. He's authored a wide variety of congestion control protocols. In the talk, he's very complimentary to TCP IP. And it's an expression of humility because when they tried to scale TCP above very small networks, it just completely fell over. It was a total disaster. And like the great man theory of history, computer science and network architecture rides on the backs of a very small number of people, and Van Jacobson is undoubtedly near the top of that list. So in the talk, he gives a history of networking and frames it in such a way as to make his new architecture compelling, deterministic, unavoidable. It's very compelling. I don't know if it's right, but it's very compelling, and I'll see if I can recapitulate that for you. The generation one was wires. This is circuit switching, this is telephony. This may, if you've studied much networking or done much reading on the history of the internet, this may all be obvious to you, but it was not obvious to me. Some properties of telephony, I should say. The first thing that you need for a circuit switched network is that you need wires everywhere, so the capital costs are unbelievable. And you can't make use of them until they are fully connected. The revenue in such a system comes exclusively from dynamically constructing a path through wires that you actually have. And this is what seemed to me a subtle point, but hammered very heavily in the talk. Calls were the product sold to the marketplace by the telephone network, but they were a side effect of the actual logic of the network itself. The logic of the network, everything about the entire system was just about building a path. And then once you had a path, you could use the path for anything that you could think of, and the only thing that people could think of was calls. But they were a side effect. And a telephone number, which looks, for all intents and purposes, like a name or an address, was actually a program. The original 4-digit numbers were two-dimensional coordinates on a 100 by 100 grid switchboard. And so you dial 1, 2, 3, 4, and you go to, column 12 and row 34, and you hook up the wires. The telephone number is literally a program controlling the system that builds paths. And this system had substantial problems when it was used for anything other than telephone calls and dynamics that trended toward monopoly. Path building is non-local. You need global knowledge of the paths, of the links that exist and their status. You have to schedule centrally. The reliability is terrible. A call fails if any link in the path fails. So as the system scales, reliability decreases exponentially with the number of links. And then, hilariously, when talking about data networking, incredibly high setup costs. You can't use the path until it's wired up all the way end to end. And I love this. So again, this talk is from 2006. And he says, if if transcontinental setup time is 100 milliseconds and you have a gigabit link, by the time you've set it up, you've wasted 12 megabytes. So this is not practical for networking at all. You'd have to fetch a 12 megabyte web page to use the network at 50% efficiency, and there's no web page that's 12 megabytes. It's pain. But in general, you can't do what you want to do with data networks with a system that has setup costs like this, because you have to send a lot of data to make it worth the trouble of setting up the link. But if you make it slow enough, it doesn't matter. And this is why the phone company loved and was wedded to ISDN, which was 64 kilobytes. At 64 kilobytes, setup costs don't, 64 kilobit, sorry. Setup costs don't matter. But this was the entire world, and it framed everyone's thinking. If you asked anyone, up until the 60s, networking simply is telephony. And all of the research that was done anywhere was focused on dealing with these high setup costs. And now I'm just, as a point of order here, I'm stealing his stuff. I wrote the slides, they're his points, I'm recapping the video. I'm not gonna say, in every sentence, Van Jacobson says X, Y, Z, but if you have a problem with any of this, it's not my problem. Generation 2, instead of focusing on the wires, focused on the endpoints. This is packet switching. It was proposed in the 60s, first published in a Rand Corporation paper, and the idea is incredibly obvious to us now. It's hard to even see the breakthrough that it was. But the idea was simply to take the wires as given. The telephone network already exists. All of this capital cost has already been extended. There is a path, somehow, from one end to another. And if you split the data into tiny pieces, you can share that path. You can't monopolize the path like you would in a circuit switch network, but you can share it. And then you can use transitivity to make the network somewhat autonomous. And that is just really two quite simple things. You put the endpoint addresses in the data, and then when you receive a piece of data, if it's not for you, you try to send it on. That's it. Everyone thought this was insane. This can't possibly work. What's more, that's not a network. He says the entire staff of Bell Labs released a statement saying this can't possibly work. It ignores everything that makes the phone network work. But the director of ARPA, Licklider, I think, he liked the paper, and he commissioned such a thing to be built. So again, ARPANET was built on top of the phone network. And to anyone experienced in networking, it just looked like an absurdly inefficient way to use the old network. It's not a network. It's just this crappy overlay thing. The data the data is redundant, right? Like you could figure out who you're talking to, just because you have the link, but instead you have all of this extra overhead. You're wasting data, putting the addresses on the packets. But that property, that it was a pure overlay, that it didn't depend on the underlying layer, it made it completely agnostic to what was underneath. It made it so that it could actually work over any kind of link. And fundamentally, it's changing the point of view. It's looking at the endpoints and it's abstracting over the path. It was a huge success. Everyone wanted one, and so immediately you had a proliferation of incompatible proprietary packet switch networks. If you're like me and you took some networking classes, CCNA kind of stuff, IPX comes to mind. I know there was others. Maybe somebody else knows. But in any case, there was lots of them. Apparently all the branches of the military built their own, and they all worked really well, but they were all compatible. But then, so this was, the paper was in the late 60s, ARPANET was built in the early 70s. By the mid to late 70s, Vint Cerf realized that since packet switching abstracted out the topological details of the network, if you just put a common header on the packets, a shared addressing scheme, common encapsulation format, you could concatenate networks together. For some reason, the name Catenet just was not a marketing coup. But they built it, and it became the Internetwork Protocol, and yeah, the rest is familiar history. But there are some interesting notes. So in a packet switch network, reliability increases exponentially as it scales up. Each time you add another link, you're adding redundancy to the system, another pathway that a small piece of data can flow over. There's no link setup cost, and it's bandwidth agnostic. It works as well over a slow link as a fast link. It does not require a hierarchical topology, unlike the phone network. Centralized scheduling is NP-hard, and the way you solve an NP-hard problem is that you restrict it to a subdomain. Centralized hierarchical routing model made scheduling tractable for the phone network, but it wasn't necessary at all. There was no central view of the network. And so those were those first three bullet points, those were the three problems that were known, the goals that were trying to be met in designing this new system. They got the fourth for free. By virtue, the same adaptive routing mechanism that lets you route around failure lets you start sending packets from day one without central configuration, because the address is in the data. You get a packet, you don't know who it's for, you try to send it on. You need an upstream gateway, you need, some kind of other node. Let me see if I... So as a sort of another meta point of order, in the talk, Van Jacobson characterizes this as the network entirely, hooking itself together, fully autonomously. I think anybody who's done much of anything with IP knows that that's, euphemistic at best. But I do think that it's an accurate representation when it's compared to the prior model. The prior model is physically running cable. It's punching down a block. It's centrally registering the existence of you implicitly by virtue of the fact of there being a path to you. Whereas in the IP network, you just need an address. And so IP, and especially TCP/IP, were so successful that they entirely changed the world. Everybody knows this. Before there was no internet. Now there was an internet. Outlook unclear. But that's not the success disaster that he means here. This system was modeled and built in a world with few machines and many users for each machine. There wasn't really data on the network to speak of. The primary use case that was envisioned was remotely using computational resources. You have, we're in Wyoming, but the University of Arizona has a computer that fills 15 rooms, and we'd like a couple, flops. And maybe, the result that would be, printed out could be loaded back into PunchDeck and sent back to us back over the network. But the data volume is tiny. The model is communication between machines, two-party conversations between machines. Now here's his list of the problems with the packet switched world. And I don't know that our list would be the same, but this is interesting. Connected is a binary attribute. Oh, thank you. The internet is one thing. You can either talk to it or not. Connecting is a heavyweight operation, so I said you just need an address. Of course, we'll pretend that doesn't exist just for this portion of the talk. Not only do you need the address has to be topologically stable to be able to percolate through the network and be addressable. And that, as of 2006, he says was on the order of hours. So you can't have a viable short-lived connectivity without a lot of infrastructure between you to make that work. To this day, the network absolutely hates things that move. IP mobility is a joke. The only way mobile phones work is that your provider pretends the entire world is a LAN, emulates everything in software. The IP that your phone is running is actually like 15 layers of overlay, and it's. But this is fundamentally true at the base models, and lots of things compensate on top of it. And then the base model itself is totally fine with broadcast, but all the transport protocols we use over it don't have any way to make use of broadcast. And this has only gotten much worse since he gave this talk with the proliferation of wireless, which is, fundamentally physically a broadcast medium. And all anybody does over it is have conversations. So I looked and I couldn't find statistics updated for today. In 2006, he says 99% of internet traffic is retrieving named data. Web pages, email messages, things of this sort. And it's quite possible that that number has gone down significantly because ubiquitous network security is almost exclusively modeled as conversation. So depending on which layer you're going to consider to be the network, even if your sort of application level patterns are still retrieving named chunks of data, that's being tunneled not just at the IP layer, but at higher layers through a conversational medium. But anyway, it was quite surprising to me. He said over 99% in 2006. And of course, acquiring content by name is not having a conversation. That is data dissemination. And so this is the shape of his presentation. And the point of it, right, is framing the success of packet switching over circuit switching as this abstraction, which it clearly is, taking things that were implicit in the topology and making them explicit in the data, and proposing that 20 years ago, the future of networking is dissemination, which can model a conversation somewhat awkwardly. Of course, you can make this work in either way. So everything that we do right now, browsing the web, anything like that, is layering dissemination over a conversational protocol. And let me check in here. That has problems that I'll get to on the next slide. I don't know why I laid this out like that. And so conversation over dissemination is inefficient, at least when it's done in a naive way. But dissemination over conversation makes the network blind to what you're actually trying to do. It can't help you. All you're doing is blasting data along. So when we browse the web, for example, the channel is secured and not the data. The example he uses, the SSL connection to his mail server does not help with spam. It's just in very clear, obvious terms, completely a layering violation. The network cannot help. Applications and users have to perform plumbing to translate from the data they want to the server they need to connect to. And then it's inefficient because the same data in the network bound for different destinations, the network is also blind to that. He says he got a chance to look at a core internet router downstream from NBC during the 2006 Olympics. And there were 6,000 copies of the same video frame of, what's his name, Bodie, the New Hampshire skier, you know, hitting the pole or whatever it was that year. But it was a huge congestion problem. The router's dropping packets like crazy, and this is ridiculous, right? It's public data, everybody's asking for the same thing. There's a layering violation here. The network can't model it. So what is his model for dissemination? Data is requested by name. Data has a name, not a location. Names are arbitrary, so they can be meaningful. This is opposed, or rather, strictly a superset of content addressing. Content addressing is to name something fundamentally by itself, usually by a cryptographic hash of itself. This has very nice properties. We can coordinate on what the name is without any sort of namespace in any real sense. There's no upfront coordination and there's no ownership of the data. It's just sort of a flat world where objects exist. And it's trivial to validate the binding between the name and the data, getting ahead of ourselves just a little bit. But it has terrible ergonomics. It doesn't encode any sense of locality. And in practice, anytime you're using a content address system, you have to build a layer over it for meaningful names, and then you have to authenticate the binding, and you're right back where you started. He argues, and I think convincingly, content addressing is useful in specific sort of narrow use cases, but it's a poor interface, and it's a mistake that many, many projects subsequent to this one have made to make content addressing the base layer. So data, again, is requested by name, not location. A request can be broadcast over any media, can be sent to anyone, and anyone or anything that has the data can respond. So at this point, we've started to close the loop back to the original Moron Labs post. Integrity and trust are derived from the data itself, not from the channel. So this is one possible interpretation of deleting the source address. It's not meaningful where it came from. What is meaningful is what it is. You have to be able to identify what it is from the data itself. And in a model like this where you can ask anyone for anything, anything that moves bits in space or time can and will be used to communicate. You can put hard drives on a plane, you can put hard drives on a truck, you can distribute data preemptively, opportunistic transport. And of course, when you think about those things, this is done all over the world. This is done today very much so. Whatever, peripheral Comcast office is closer to me probably has a rack in it full of drives, full of Netflix content. But the retrieval of that data doesn't really happen in the network in any meaningful sense. I talked to Netflix's servers on EC2, and they geolocate me, and then maybe they even authenticate on the side with the CDN node that they've paid Comcast for this peering relationship, and then they give me, finally after all of that, some session scoped identifier that lets me go and get that data from them. But all of that could simply be in the network. So if you communicate your intent to the network, if that's legible in the data, the network can do more for you. Well, this one's particularly interesting. A request response topology. Request data by name, get a response that you can authenticate, matches that name, has that name. This allows fine-grained control of incoming traffic for quality of service. Now, everybody knows that, the network core is very fast, it can hold lots of data, and it gets slower as it gets out to you. And so congestion happens at the transition from a fast link to a slow link, not the other way around. On your home network, you have control over what you send and how fast you send it in what order, but not what you receive. You have zero control over what data gets prioritized. Now, you could build an ad hoc protocol and the ISPs could deploy it, and then you could sort of negotiate with the ISPs, I want my video call, to trump my kids, Disney Plus. But there's not a huge incentive for the ISP to go to all the trouble to build that. And so, mostly things kind of work. Sometimes they don't. And there's not really a good option in the existing protocols. But when you are requesting data by name, you're in control. One request equals one response. The response is going to, follow back the request. So the order, the rate, prioritization, all of that is in in your local control. Because it's request response and it's a poll-based model. And then of course, if the name of the data is legible to the network and lots of people are requesting the same thing, then that can be handled very efficiently. You sort of get a multicast effect for free. This is yet another thing that was probably slightly more compelling in 2006 than it is today. Most security protocols, again, are conversation oriented, and HTTPS is everywhere. I don't think that's a necessarily mathematical result, but there's no question that group encryption protocols, where we will have a shared identifier as opposed to two-party or group encryption calls, where each of us have a paired identifier, they're less common, they're more complicated. It's definitely worth calling out as something that changed in the last 18 years. So now we're getting to, pretty familiar properties. This kind of data dissemination model requires that the data be immutable because there isn't a path. It doesn't really have a lifetime. It can be stored anywhere. It can traverse any link. It needs to be referentially transparent. There's a name for the data has that name, those things don't change. If you need to produce a new version of a piece of data, you supersede the old data, you do that under a new name. I'm sure this is very familiar to everyone here. Interestingly enough, in his model, and this is something that we should think about, but we haven't done in any meaningful way yet. There's two layers of authentication. There's basically a mutable alias layer, so a well-known name, where the binding from that name to data can actually change. And that's expressed as a binding from a generic name to a specific name, and then a binding from a specific name to a piece of data. And his example, he asked the network for newyorktimes.com/today, and he gets back a response packet that has two message authentication codes on them and a full name that includes the date. Whoa. Oh man, now you're going to see all my slides ahead of time.
Go faster so we don't read them.
Point Yeah, I wonder if the battery's dead.
You can point it that way.
Does this work better?
Can you use your computer to go back slides?
No. It's not even plugged in, it's just for me. Whoa.
There you go.
Amazing.
Look at that. All right, so that's the talk. I've already made this point, basically. His framing of the history of networking and the future of networking is that what has been successful is to take things implicit in the link, in the topology, in the conversation, and make them explicit in the data, abstract over the details of what is underneath it, and each new step of doing that unlocks new capabilities. So this talk, again, it was given 18 years ago. It was given to the right people to make this happen. In the intervening time, Ben Jacobson was working at Palo Alto Networks. He founded the content-centric networking project. They built software. They published specifications. Palo Alto Networks was acquired by Cisco. Ben Jacobson left Cisco. He got a National Science Foundation grant. He started the Name Data Networking Project as a fork of the Content-Centric Networking Project. There's 20 universities involved. So I'll start at the bottom of my list and work my way up. Name Data Networking is a fascinating project. It has produced massive amounts of very interesting resources, but it is very clearly stuck in a research trap. Pick any computer science tech buzz code that you can think of and Google your buzzword and NDN, and I guarantee you will find a paper. I just don't know how else to say it. Some of them are really good, and a lot of them are just, some Joe Schmo's master's thesis. I'm sure Joe's a good guy. And the rest of these are basically my guess. So I don't think that the benefits are really worth switching if all you're going to do is lay conversations over the top of a data dissemination protocol. And everything that exists at this layer is conversation oriented. I already made the point about security, right? That has, if anything, gotten more difficult in the intervening time period. Even something that you'd think of as a group protocol like Signal doesn't send the same message with the same key under the same identifier to everybody in the group. And I'm not a cryptographer, so I'm not going to promise that you can get the same properties by doing it in that way. But I just suspect, quite frankly, there hasn't been a need, and so those protocols in that form haven't been developed. You can always come up with a naming scheme for things and always share some amount of derived, in ratchet, hashed data, whatever. There's got to be some degree of multicast possible in that kind of protocol. But it doesn't really exist. You can do a much dumber thing, which, jumping further ahead, I think we will, which is just, have people in a group, there's a key for the group, you rotate the key periodically, kick people out of the group if they cause trouble. But, that's better than a lot of things. That is certainly secure against the underlying network, but the trust model that's sort of shared in the group is very high. Another thing to call out about security, things like Signal, I believe the noise protocol framework as well, OTR before Signal, they really liked this idea of deniability. And so as the protocol would ratchet forward, you'd actually leak the old key material into the stream. So after some number of messages, anyone who observed the message could have forged it. And this is really compelling if you're worried about a journalist under some oppressive regime. It's amazing that's always the example they use. I don't know, maybe the journalist should have moved somewhere else. I don't think it's the most compelling feature for a security protocol, but more importantly, Urbit's really never been built to do deniability. Urbit does pseudonymity, and the association between the data and the identity is strongly attested to. If you want deniable communication, use another pseudonym. We got a whole 128-bit address space of comments, go nuts. More obvious, similar to the protocol layer, to really take advantage of data dissemination, you need new application paradigms, right? Everybody is a publisher now, right? Conversations are derived through this, mutual dance of publication. And it's a really different way of thinking about applications. But if you don't factor your applications in that way, there are applications that are factored in that way, and they would get an advantage, the web browser, for example. But in general, you kind of have to turn your thinking inside out to write applications that way. So I would propose that that's also a big reason this hasn't taken off. And then finally, and this is pure rumor, my understanding is that content-based networking protocols are fairly ubiquitous inside big tech. That Google uses them, and Cisco uses them, and Netflix probably uses them, to manage their CDNs that are distributed all around. And so I think a big part of this is just the overall incentive structure of the internet being totally screwed, and nobody can ship any new protocols regardless of how good they are. But like I said, it's conjecture. Maybe it's a bad model. When we look at NDN from Urbit, right, we're coming all the way back around, the inspirations are obvious. I'm sure there were other sources of inspiration as well, but Urbit is built for this in some very concrete way. We all know about the referentially transparent namespace, but also we have some nice properties that constrain the problem and make it easier. We have a node model, we have a PKI. And in the end, the PKI is totally abstracted over, right? You put some kind of like certificate identifier on the packet, and then there's some other way to go and get a certificate, and maybe we'll do a web of trust model, and this is all familiar. By virtue of having a node model and having addresses, we don't have to dive right into content-based routing. The NDN model is nodes have links. It knows that it's got a Bluetooth radio. It knows that it's connected to Ethernet. And it starts out by just blasting out requests over every medium. And it dynamically builds up a forwarding information base, as they call it. And then it tries to do path-based prefix routing. And then you need protocols on top of that to, your BGP or OSPF kind of protocols to, share and negotiate and authenticate routes. And all of that's awesome, and maybe we'll do it someday, but it's hard, and we just don't have to do it now. We have a node model. Every name in the namespace, every path starts with a ship. The ship is a first-class routable identity. So we can just collapse the problem space way, way down. The need for new application paradigms is no problem at all. Like, we're here. That's table stakes. But conversations are kind of nice. Like, it's just a very natural way to think about communication. We talk about a peer-to-peer network, and like that just sounds like a conversation. And so if the model pessimizes conversations too much, it's not going to fly. And you can generalize that and just say, what's not nice about the conversations over NDN. We'll get to it in some detail, but in general, it's the request pull-based semantics. You really want to be able to push a piece of data out to somebody, get their attention. You also just want that for change notifications. And then the other thing that I should mention, as far as the namespace is concerned, is that NDN is sort of equivocal about referential transparency, not just in the way that I mentioned earlier, where there was like a generic name and a more specific name and multiple levels of attestation, but they're also really attached to this story, this zero configuration story where, it would have been nice actually, but I'm here in the room and there's a projector and the projector is broadcasting itself as a name and I can just, connect to the projector but that's not a globally routable thing. That's not there's not going to be a trust root that I'm going to be able to discover for that thing. So they end up with a kind of two-tier system where there's some names that are locally scoped and some names that are globally scoped. There's some names that are referentially transparent and some that aren't. And in Urbit terms, it's just sort of mostly questionable with a couple of exceptions that I think we'll get to. So, this spring we shipped Finae. And Finae, it is not at all wrong to think of Finae straightforwardly as named data networking on Urbit. It is a request response protocol. It uses the namespace. You issue a request that is a path in the namespace. You get a response that is a signed binding of the path and the data. The data is, what we call a page, an arbitrary marked noun. So it has a tag on it that gives you some kind of hint as to what type of data it might be, and then any noun. And we're using this drives OTA upgrades and has since May, I think. Yeah. And it's highly cacheable. When you get a request, if it's for a packet you haven't produced yet, you actually produce the whole batch, a whole window of packets around that, and you eagerly push that out to your runtime and subsequent requests. Not only do they not hit the event loop because they're pure reads, they don't have to be logged to disk, anything like that. They actually don't even hit knock. It's a hash table lookup. But it's incomplete in some important ways, and it's really expensive. So this was the right decision to ship something, but it's an obstacle. Finae, request and response packets, this is dissemination over a conversation. It uses the same framing as AIMS, and we'll talk about AIMS soon, but that means that there's a source and a destination address and intermediate nodes. They get a request, they have to rewrite, or have a response, they'd have to rewrite the metadata for each destination that they're going to send it to. It's also not really an independent protocol. The routing is completely parasitic on AIMS. If you couldn't talk to somebody over AIMS, you can't talk to them over Finae. So those are the things that are incomplete about it, kind of below the line. And then above the line, you can't really use it for too many things. The basic model is that it's public data. So you could roll your own encryption and put ciphertext in your namespace, or you ship public data, source code for base, source code for apps. That's pretty good public data. Maybe you could argue that the group's contact profile thing, that should be public. Maybe it's effectively public inside the network, but there's still a difference between public inside the network and public outside the network. It's hard to think of too many other things where you're like, oh, sure, yeah. Anybody on the path, have at it. And then, even if you ignore that problem, and the problem there basically being we don't want to force user space devs to roll their own crypto, your patterns of using it from user space are fairly limited, and initially were very limited. And so this probably deserves a little bit of a tangent, but before I do that, let me check how I'm doing on time. Holy crap, I'm doing terrible. Long story short, the main job of the Urbit kernel is to guarantee referential transparency. If you let apps do whatever they want with the namespace, you can't guarantee referential transparency anymore. Right now, it's really locked down. We want it to be much less locked down, but they have to be well-defined patterns that are legible to the kernel so it can still maintain its invariance. All right, let's, also it's really, really, really freaking expensive. So this was, I just ran this and copy-pasted the output this morning. On a fake Zod, it's an M2, that is a fast machine, and what I am signing is the number 0. it took 4 milliseconds to sign the number 0 and 6 milliseconds to sign and then verify the number 0. In Finae, we sign every message, and then we sign every packet. So it works great if the data is going to go out to a lot of people, you've amortized the cost. You don't have to log events, right? Requests come in, they're pure reads of the namespace. They parallelize for free once Ares is here and we have a multi-threaded runtime. Will be great, we'll take advantage of this, but it's really, really heavyweight. So I'm going to pick up the pace. To make it less expensive, we're going to go from we sign every message to we sign most messages. Content addressing, for when it's useful, needs a special carve-out because that's trivial to verify. There's no reason to sign it. When I get to AIMS, I'll talk about another carve-out. And then we don't want to sign every packet. Packets aren't that important. We have to be able to validate that a packet's part of a message and its position in the message, and that's it. A Merkle hash is great for that. There's a new version of the Blake hash, Blake 3. It is a tree hash. There is a serialization of it for a verified streaming use case called BOW. We have to tweak it a little bit for our use cases. I really wanted visual aids, but I don't have them. So I'm going to just keep going. It's a tree hash. It's not rocket science. To complete Finae, remove the conversational envelope. Requests are anonymous. They don't have a source. It's just a read for a path. You're still reading public data. You route requests statefully. If you get a request that you can't satisfy and you are configured to forward it, you remember the request and you forward it on. Later on, when you get a response, you just return it to whoever requested it. So this is very much like a sort of stack discipline, function call discipline. Think of requests weaving their way through the network, leaving breadcrumbs, and responses coming back, eating the breadcrumbs. Those are the short term and the long term. Subscription reform. User space publication models that are legible to the kernel, put lots of data, and the namespace needs group encryption to be useful for general data. But even so, it's still not complete. We do all of those things. We cannot shift all of our communication to this model. Frontier discovery. What's the latest version of something? Long-lived requests. You don't want to pull all the time. And then after some interval where it doesn't even, they're not going to keep your long-lived request around. It's been too long. You need notifications. Consider a chat channel. It might be quiet for months at a time, but you actually want to hear it pretty quickly when somebody posts in there. So like an exponential back off, long pulling kind of thing, it's not going to work. There are designs for these things. They're out of scope. AIMS. Gonna keep going fast. Everybody knows AIMS. This is how AIMS is always described. This is true in a sense. From user space, if you squint and forget about some of the things you can do in user space, it's true. It's not really exactly what AIMS is in its own terms. AIMS is absolutely Martian networking. We don't process a packet differently depending on where we hear it from. There is a source and destination in there. We use them to look up keys, basically. So it's somewhere in between. It's not TCP, right? The semantics are not session-based, they're not connection-based. But it's like a very special, narrow corner case of data dissemination. It works actually really well over a variety of network conditions, but we already talked about why things can work that way, and that's because it's really, really slow. But it is a good least common denominator, right? They're MTU sized, under 1,500 byte UDP packets. You can send them over IPv4. IPv6 is never going to happen, people. I'm sorry to tell you. This is always going to work. But it's also really, really expensive. So every message is a transaction. Arguably, this is a really, really nice thing. It lets you build reliable, distributed state machines. Every packet is a transaction. It's Like, how much do you really care about packets? It has really, really, really strong invariance. And the model is a total mismatch. For our current application model, and also for the future application models that we're thinking of to take further advantage of data dissemination. So it's a really, really strong, perfect castle in a place that nobody wants to live. And then we use these transactions not only to tell our sponsor, or in fact our galaxy, where we are, but to keep a stateful firewall NAT pinhole open to them, which means that we perform these transactions every 25 seconds. It's illegible. You look at the packet, all you can see is the source and destination ships. You can't correlate packet to the message, you can't correlate the acknowledgement to the packet, right? So it's a transaction. Every packet elicits an acknowledgement back. The acknowledgement for the last packet in a message is the end-to-end acknowledgement, which means the message was processed. There's all this structure here, and it's completely illegible. All you have is blobs at the network level. You can't do anything with it. You can't prioritize based on flow. You can't correlate them. You can't route them differently. You can't say, this one I care about low latency, this one I care about throughput. No way to do any of that from the network itself. It's theoretically transport agnostic, but all you can do is what it does. In practice, it's UDP over IPv4, fixed size fields, very, very constrained. So when I started thinking about this in detail, I really wanted to figure out, could we run AIMS over Finae? Could we just take the network we have that we push everything through and rejigger it so it has all these nice legibility properties, and so you can correlate things, and if people happen to ask for the same thing, they get it multicast efficiently. If packets are dropped and they ask for them again, it hits a cache somewhere in the middle of the network, and you can do it. But it's silly. So to poke, right, to send a message to you, I send a request asking you to acknowledge the message that I sent to you, that I haven't sent to you. And you notice I haven't sent you the message, and you're like, oh, I can't answer his request for the acknowledgement because I don't know what the message is. So I'll go ask him for the message. And then I send you back the message in response to your request, and then you're like, okay, yeah, sure, I got it. And this totally works. It's completely legible. It has all of the nice data dissemination properties we spent the first half of this talking about. But it's double the number of round trips. It's double the number of packets. What else did I write down about this? Nothing. It's just silly, right? It's elegant. You take two things that are very different and you turn them into one thing that is very, very simple. It's very compelling to be able to do that and build everything out of it. But it's Urbit is the slow computing movement. But there are limits. Where am I here? In addition, to it being cartoonish to double the number of round trips and acknowledgements when you do this naively, you have to sign and verify. Right? So the packets are already ciphertext, but now you're attesting to them globally, and I just showed you how long it took to sign the number 0. This will take longer. But we talked about this for a while and came up with a model that I think has almost all the nice properties of the trivial toy dissemination model there, but it actually doesn't pessimize almost anything of the things that we're doing, and it unlocks a bunch of new possibilities and capabilities. So I want to run through the model. We're going to have to sort out the names right? We have aims and Finae. If we're unifying them both, are they aims? Are they Finae? Are they something else? I called the messages the obvious things that came to mind, but like there's already names for some of these things in different contexts. These names officially come from other contexts. So peek is the Arvo's interface to read from the namespace. Poke is Arvo's interface to inject an event. These are named, out of homage to BASIC. And then page, I said earlier, page is the marked data. And so it's actually like completely absurd to call this page because this is the path and the marked data and the signature that binds them all together. And anyway, I apologize for using perfunctory names, but they're what's there. The idea is a single request protocol, message-oriented. So it subsumes Finae. Peek and page are keen and tune. This is exactly the same. But poke subsumes aims. So we have stateless read request, stateful write request. They both elicit the same kind of responses. It is a one-to-one request-response protocol. The correlation between request and response here is as trivial as it can be. It is an exact match. No funny business with path prefixes and anything like that. The poke write request is the pattern that we described, but it's concatenated down into one thing. So it is a read for the acknowledgement plus, I did something to my audio, plus a response to the read for the payload. So formally, I'm saying, can you produce an ACK for this message? Oh, but by the way, here's the message. And literally just sticking them together. So it has the same semantics, but it also has the same number of round trips. It's message-oriented. This is a big difference from aims. Aims actually encrypts packets individually. This was a reasonable decision because you want the packets to be rescindable across rekeys, and we needed, for various reasons, to encrypt the packets up front. But what that means is that in aims, you don't really have a clean, stateless transition from the packet level to the message level. We want this to be really dumb. The packets matter, but they don't matter too much. The messaging layer is primary. The messages are public, and packet authentication is derived through a tree hash or possibly self-attestation if it's content addressed, but derived from the message itself. What the packet says is, I am part of this message, you have a signature for this overall message, and a root hash, and so you can trace down through the hash tree and find that I'm the fourth fragment over here, validating it with hashes each individual step instead of producing lots of signatures and paying the cost of verifying them. But we still want packets to be specified. We need a least common denominator. We want it to be practical to run minimal run times that don't need a sophisticated I/O layer to talk to the network. So the packet level exists, it's in Arvo, it's sort of on by default. But the idea of specifying the message layer as primary is that if you have a better way to talk, you should use it and just bypass the packet layer entirely. Now again, these are public messages still, so let me check on the time. I already said they're concatenated together. One additional optimization that we can perform, because simply taking the read and the response and sticking them together to make a poke, you'd still have to sign it. And if you read it, if you unrolled those operations and performed them individually, in the model that I'm proposing, it would be signed. But everything has a name on it, and the name can be as precise as it needs to be. And so the idea is that if the message, if the payload of the poke fits in a single packet, you also elide the signature. You concatenate it together under a slightly different name, and all you need to send is the authenticated encryption that we're already using, because in fact, this is formally the two-party conversational case of the data dissemination. There's no reason to attest to it to anyone else. Now, if the message doesn't fit in one packet, you want to sign it, because signing it is the means by which you will validate all of the other individual packets that make up the message. And so when you get a poke message like this, it always includes the first fragment of the payload. And so that tells you where you can go to get the rest of the data and how big it's going to be. And when you do that, you get some real, real surprising benefits that I actually didn't model. I was looking for the legibility, I was looking for flexibility, I was thinking about transport agnosticism, these kinds of things. Can we pull the layers together? But when you factor things like this, the total number of writes, event log writes, involved in sending a message, an AIM-style message, where it's a command, it's being pushed from one ship to another. It's reduced by the number of fragments minus 1. We go from 2 times the number of fragments, and a fragment is 1 kilobyte, to the number of fragments plus 1. And on the publisher side, on the sender of this command, the writes involved are reduced to 1. And so this actually really, really matters for the Gall subscription model. In a Gall agent, in Gall's world, a subscription is one thing, and there's just a set of ships attached to it. But when you just step over the line from Gall's world to AIM's world, that's in conversations. You're having a separate conversation with each one of those ships. Nothing is shared except the actual data, but the identifiers aren't shared. It's not legible to the network. You do all the work over and over again, and then you communicate in this model where every message is a transaction, every packet is a transaction. The message itself is routed as a first-class citizen. The acknowledgement is routed back as a first-class citizen. There's lots and lots of overhead here. And the subscription reform model and pushing everything to Finae and having a new application model that lets user space meaningfully populate the namespace solves all of that in like an absolutely ideal way. But it's a big lift. It's a lot of changes. It'll involve rewriting applications. What can we do in the meantime? This is a pretty big deal, and the amount of a big deal that it is very obviously scales up with the size of the messages, which is kind of funny, because normally we wouldn't want to encourage you to send really big messages, but. So the publisher pushes out this poke message, whether this is like a plea, command, or a boon response to a command. They're all the same thing by the time you get down to this layer. And regardless of how big the message is, it does not have to do anything else except maybe resend that one request. The receiver of that message looks at it and sees, is there more data missing? Do I need to go out and get more data? It reads it from the publisher. Those reads don't hit the event log. When the interpreter can be parallelized, those reads will be run in parallel. If anybody else happened to have read it beforehand, it'll be in cache, all these kinds of things. In the Gall model, that won't be, because each one's under a different name. But even so, those are a couple of really substantial wins that just kind of fell out of looking for legibility at this layer. And we do all of it with no additional network round trips, and for small messages that fit in a single packet, no signature overhead. Popping the stack here. We need to optimize Finae. It's too expensive. So we talked about the Merkle hash model. And I do apologize that I did not prepare a diagram. I will take just a couple of minutes and try to describe this, and you can visualize with me. So picture a complete binary tree. That means, for whatever depth the tree is, all of the branches are completely filled in. The tree is hashes, Merkle-style hashes, where the hash of a node is just the hash of both of its children. The leaves are the data fragments. We're going to send the data fragments in order, the leaves of the tree. And to each one, we're going to attach the next hash, the next best hash that we can, so that they can validate things in order. In the tree, that is a pre-order depth first, left to right traversal. So you start at the root, and then you go to the left child, and then to the leftmost child, and leftmost child down to the leaf, and then you go back up to the first right branch that you didn't take, and so on. What this means is that we can validate every fragment individually, so long as we validate them in order, and we have to accumulate a few fragments up front before we can start validating, because you need the complete path from the root of the tree down to the first fragment before you can start validating anything. That you can validate each additional link in the path, and you start with a hash of the assigned root hash, and then pairwise hashes. And so what this means is logically you have two sequences that are multiplexed. You have a sequence of the fragments of the message, and then you have a sequence of the hashes in this traversal order, and as you receive them, you collect them into the appropriate data structure. Once you've received log2 of the number of fragments, then you'll be able to validate each individual one after that, so long as you process them in order. Maybe this can be improved. There's a certain amount of overhead in the data here, but this is pretty nice. And one of the things that I really like about it is that it's a nice incremental step towards transport agnosticism or informal depacketization, right? Everything is really legible here. So Arvo emits the first request, right? You get that back. Ver could just step in and say, get back the first response. I'm just going to start spamming out more requests. I'll do my own congestion control right here. Maybe I won't inject any of the fragments as events until I've gotten to log2, so I don't inject anything that can't be completely validated. Maybe I won't inject anything at all, and I'll just validate the whole message and inject it in as a message. But there's lots and lots of nice waypoints along the way where we can build these things, and they're locally useful without like heavyweight, complicated designs. So I talked about the transparent multicast. The idea here is that for an intermediate node, request comes in, it occupies a little bit of state for a short period of time. If another request comes in for the same piece of data, it joins that first request and it stops there. It doesn't transit upstream. And then when the response comes back, the response is multicast out to the requesters. Really compelling for anything that anybody's going to ask twice. Maybe not so compelling if it's only ever going to be asked once. So maybe you do it, probabilistically. Like I said, this part of, there's questions about exactly how worthwhile that is, except for relatively narrow categories of high fan-out data. I still think that the model is the right model because of these other benefits from legibility. And it might even be worth it even if we don't multicast all that often. But it's worth calling out. Right now, we can forward statelessly. In this model, you can't. Very similar kind of cost-benefit analysis. Any node in the network can cache, poisoning the cache. Then all of a sudden, it's not so cool, right? So you say, well, everything that goes over the network can be authenticated, everything can be validated, but it's really freaking expensive to validate everything all the time. You just can't have a practical relay system that does that. So there's all these models of, this is a problem, that comes straight from NDN, it falls out of the design, and they have different models of probabilistic validation, and if you get a bad value on a request, the next time you issue the request, you put a digest in there as an exclusion, right? Like, I'm asking for this thing, last time you gave me this other thing, it's garbage, don't give me that garbage again, I still need that thing. Those are options. A really dumb thing to do is, like, our relays are going to be full nodes, only cache the things you've actually validated. You can transit the other stuff through. It's really easy. We can do that today. We can think about the hard stuff later. We already talked about quality of service. The message orientation, the way I'm thinking about this, again, this is the public message layer. So if you're sending encrypted data, these messages are ciphertext. This is a practical, granular story around transport agnosticism. It's request response. If you happen to know that there's a gateway somewhere, you can do the request response over HTTP. If you happen to know that a socket is available, you can stream the whole message body, response body, without packetization, back over it. And you can make that decision at any point in time. You don't have to make it for the whole peer, or you don't have to make it for everyone that you're communicating with or anything like that. Again, this is just this trivial point. The intent is legible in the data. The network can do more for you. And then we talked about informal depacketization and congestion control. Now, this is something that Ted only just talked me into like a couple of days ago. And I have been really reticent to look at message-oriented network protocols that completely bypass the authentication layer or the encryption layer, because I worry about not having something that's one thing, but just having an agglomeration of things. It's like, well, what's the Urbit network? It's like, well, there's the Urbit UDP network, and here's the Urbit WireGuard network, and here's the XYZ, right? And it's like, are we really gaining anything from this if we actually just agglomerate things and we pay the full complexity of the Cartesian product of all the things that we support? It's like, yeah, maybe it's still worth doing if the wins are big enough, but it's very unpleasant, very inelegant. But if you think about what I just described here of the public message-oriented layer living in the namespace, again, this is ciphertext, this is signed. And if you can lay out the names properly, and this is fairly trivial, then the packet messaging layer is in the namespace as a pure overlay of that messaging layer. What do you append it? It's like fragment, whatever, or something. You know, you just kind of extend the path, and there you go. Now it's the packet namespace. It's the same thing. You don't have to materialize those packets in your state. It's a computed, you know, non-materialized view over the messaging data. But if you can lay the namespace out correctly, and this might be tricky in some circumstances, but in some circumstances it will be straightforward. You can just extend that and say, well, the true data layer, the true messaging layer, the deepest, most meaningful names is the private messaging layer. It's not encrypted. It's the actual names that you would use in your applications, the actual data that you would use in your application. The public layer, the encrypted layer, is a pure, non-materialized view. It's computational projection out over that, and the packet is another layer on top of that. And you don't really have any complexity. You've just specified these things as pure functional derivations of the base thing. And it's not the most efficient thing in the world, but is Matt here? Matt. Yeah, you know what I'm talking about. Persistent memoization. Matt's going to tell you all about it. It's going to be great. It's the solution. I'm really looking forward to it. So then if you've specified this in 3 layers like this, and you come up with a trusted channel, right? You can punch all the way through without really any additional complexity. You can map backwards through the namespace, through the layers, just by convention, to actually get to the raw data. And so if you are Aqua, right? That's what you want to do. You want to pass a pointer to the data as it's persisted in the other ship. Aqua is a cool little Gall app that is a virtual bear, and it means that you can run a bunch of ships inside your ship, right? You have homoiconic system, we have metacircularity at every layer. It's kind of a toy right now because of runtime limitations and because it hasn't needed to be really much more than a toy. We've used it for integration tests, right? Spawn up a bunch of ships and so it's got a software-defined networking layer, and then it overlays its fake I/O drivers onto your real I/O drivers. And in some ways, this is hilariously inefficient. But if a ship isn't too busy, it really might not be. But similarly, if you're in a sophisticated hosting environment, right, and you have your own software-defined networking, you have your own channels, you have some mesh that connects the nodes, or maybe it's not your entire hosting environment, maybe it's just this particular VM, right? You know what all of these ships are. You just pass the data. It's not even going to escape. So this has always been a goal. I haven't really known how to accomplish it. I think that this is a relatively low-cost way of accomplishing it, and I'm excited about that. So here, this is a really dumb thing, but it's actually one of the things that we started with. I mentioned it earlier. Really important meta point. The internet is actually request response, not the web, the internet itself. In the presence of stateful firewalls, I can't send you data unless you've sent me data first. And what is it trying to do? It's trying to jerry-rig request response semantics on top of this arbitrary packet network. Cool thing. If you actually model your overlay network as request response, like you don't have to jump through extra hoops to do that. You're going to play well with the direction of everything. And again, IPv6 isn't happening. You don't have to worry about it. But even if it were to happen, it would still have stateful firewalls. So it's not purely a NAT problem. And in stateful firewalls and also in NATs, those bindings, you send out a request, so now somebody else can send you a response. They tend to be pretty short-lived, around 30 seconds. So if you're behind a NAT, you got to ping all the time. Here's back of the napkin math. If it takes 5 milliseconds to process an event, and every ship is pinging every 25 seconds, then if a galaxy only ever processes pings and does nothing else, maybe it can handle 5,000 ships. So if the network only processes pings and does nothing else, maybe we can run, 1.2 million ships. It's a joke. Tlon ran into this as an actual scaling limit this year. And so the ping app now has a no NAT option, which is an emergency bypass, and it just turns it off completely. And this is totally fine, if you know exactly what you're doing and you're really, really sure that you're not going to screw it up. Because if you did screw it up, the ship just falls off the network. It's completely not discoverable. But the solution here is just not in any way rocket science. There's two different things that are being, two different roles performed by pinging here. And one of them is this discoverability problem, right? If your route changes, you have to tell whoever's going to forward packets for you, because how else would they be able to forward packets for you? They have to know where you are. But the route maintenance is completely orthogonal. And so what we're going to do is we're going to use stun, not by analogy, but the actual stun protocol for route maintenance. This is a nice, easy little win. We can say your Urbit is a stun server. The stun protocol is the most trivial thing ever. And then we're like one step closer to supporting WebRTC out of the box. And all it's doing is pinging back and forth. When you get a stun request, right, what it says is, what does my IP address look like to you? And you take whatever address you heard it from, you write it down in the response. You actually have to mask it out because NATs are really dumb. And if you don't mask it out, they'll rewrite it not just in the header, but actually in the response. And you send it back. And so what we do is we establish the route in the same way that we always have, through a formal ping. And then once it's established, we maintain it with stun, and we save the response, and we compare it each time. Has it changed? Have we moved or have they moved? Have we moved or have they moved? And if we stop hearing stuns, we fall back to formal pings. If we get a response that's different from whatever we had saved, we send one formal ping. And so it's, no NAT without the operator overhead. And then in the course of the research for this line of effort, we came across a couple of things that are immediately actionable. I don't know how soon we'll be able to get to them ourselves, but I wanted to mention them here. If anybody wants to do this, come and talk to me. So there's been a long-standing problem where Urbit is actually really crappy communicating on a local network or communicating on the same VM. You can get into situations where if you put a moon next to your planet or two moons next to each other or something, they just won't communicate with each other. It's possible that that's your NAT not supporting hairpinning, which is where you send a request out to this public address, but the NAT realizes, oh, that public address is me, and I actually had allocated that over here, and so it just hairpins in the NAT and comes back around. But like everything else, some support it and some don't, and it's a pain. But you can use MDNS, which is used in a bunch of zeroconf protocols, and that's just DNS without a server, to just like chat over the local network and be like, hey, I'm such and such. And then you can listen for, hey, I'm such and such, and you just like send directly to them. And there's a couple of open questions, but they're tiny implementation details. Anybody who wants to do this, I'm dead serious. We should absolutely do this. This would be great. And the other thing that we can do for real whenever we want to is actually real NAT traversal. And I can say what that is in a sentence. Not what we do right now. I'll leave that a mystery. But real NAT traversal is, you have a side channel to talk to somebody. Each of you figure out all the possible inbound routes to yourself that you could discover. You exchange the sets, you try them all, you pick whichever one works the best. That's it. Again, not rocket science. And that's it. This is going to be our top priority for the network immediately. Questions?
Hey, you hinted at it a couple times, but could you say a little more about what the implications would be for running Urbit on a mesh network?
That is a good question. I can't. It's a great question. I'd have to think about that. I haven't thought about it at all.
Yeah, cool.
So what's the timeline on all this?
You'll have to ask my boss.
Soon. Like to hear that soon, TM. Can you explain more about the, sort of the caching as it pertains to the verification or like a depacketization and kind of with this new kind of like Merkle strategy?
So there are two different kinds of things, I would say. Edge nodes, originating edge nodes, publishers should obviously cache, and there's no trust concern there, right? They produce the data, they'll keep it available, in a way that's easy to deliver, no problem. Relays can cache anything, but you have this poisoning problem. Poisoning problem probably stems from a routing attack, so how likely it is depends on your routing model in some more detail, but it's still kind of a nasty corner case. And I'm not sure that the intermediate caching is worth the risk or worth the complexity of this like hash-based exclusion model on the requests. So what I would suggest is our relays, in this model it's possible for a relay to be, a normal program with ephemeral state. It doesn't have to be an Urbit ship. It needs some metadata. Part of the goal is to get the exact metadata that it needs precisely delineated and minimal, where right now it's like the whole PKI. So for now, while relays are full nodes that are making their own requests, what I propose as the model for now is they only cache the responses to requests that they sent themselves, and they only cache them if they actually process them successfully. So you just take a subset of the traffic that goes through and say, I verified this subset, so I'll cache it, and push the rest of it down the road. The depacketization thing is much dumber, right? So like a request goes out, it's emitted from Arvo, it gets to Ver, it's going to send it over UDP, or it's going to send it over HTTP, or it's going to send it over WebRTC, or whatever. It's just a request, it's a path, it's screaming the path out into the void, hopefully in the direction of the actual ship. When it gets a response, right, the response contains the fragment number and the total number of fragments in the message. So it's easy, really easy for it to issue the request that it needs. It's just incrementing a sequence number. And it can do congestion control and open that window as wide or narrow as it wants. And the relationship of the fragments to each other comes from this hash tree. So it can say, here's everything reassembled. It all matches the hash tree. Here you go, Arvo. Arvo just verifies the signature.
And when you say reassembly there, like, is this all like one ship that is doing the verification for each of the different fragments? Or is this a distributed process?
Oh yeah, no, it's local. You got to do, who you trust is your own business.
Do you see any reason why we couldn't distribute some of this and kind of do like...
Yeah, you could. You'd have to do it over a trusted channel, right?
Yeah. Like maybe if you had like an incentive layer to prevent like cache poisoning or something.
That part, I'd have to hear more ideas about. It's not immediately obvious to me. But if you had a WireGuard connection set up to your star, and your star is like, hey man, I'm going to verify everything for you, and you're like, oh, that's great. I'm running on a potato, and I really trust my star. Sure, totally.
Gotcha. Thanks.
Any other questions?
Is the thing about the persistent sort of memo cache, like with respect to like what exactly?
Okay, yeah, so I'll elaborate on this just a tiny bit. I'm not going to steal Matt's thunder. We have memoization in the interpreter right now. Knock is a formula computed against a subject. Barring some really nasty corner cases that we should get rid of that we're not going to talk about and are just details of the virtualization layer. It's totally referentially transparent. You get a subject formula, you're always going to get the same result from that. So there's a hint that you can pass to the runtime and tell it, memoize this computation, which is before you run the computation, check and see, do I already have the result for this subject and formula? If you don't, you compute it and you stick it in the cache, right? If you do, you produce it from the cache. That cache is very short-lived. It only stays in one virtualization context, again, for those really nasty reasons that I don't want to talk about. But if you can make it live across multiple events, now you have a really nice model where instead of materializing all of your pending packet queue in your state, you just express your pending packet queue as a function that traverses the message and jams each of them and encrypts them and all of that kind of thing, and then you memoize that. And if you ran out of memory on your VM, it's free to throw that cache away and say, I'm going to trade time in the future for space now. I'll recompute this data when it's asked for.
Okay, yeah, I was thinking like kind of maybe like in the other direction where like if you're like verifying the signature through the event loop, what the runtime could do maybe is like
you can prime the cache.
Store,
yeah,
and then
totally.
And then maybe like the jet for decrypting then just like removes it because you're not going to verify it again.
Yes, very much in favor of like special cased caching like that. Some other time we'll talk again about how we want to do parallelization through cache priming, thunk replacement kind of thing.
I had one other question, which was like maybe a bit more detail on how like the poke requests are like a peak and then a page, I think is what is that?
So the peak is just a path, right? Encoded, packetized. The page is the response to the peak. They're always one-to-one, so you can't like request the whole message and get back a whole bunch of fragments in response. You request the first fragment, you request the second fragment. It's all one-to-one. The poke is the request for the acknowledgement, first fragment of the payload. So the request for the acknowledgement looks just like the peak. It's just a read at the path.
Okay.
It's unauthenticated. The data itself, the payload, is authenticated. It's a response to a request for the message, right? And you just short circuit the
I see what you're. Yeah, so you don't have to do the round trip because you already started sending the poke before they request the acknowledgement.
Squeeze the packets together.
Got it.
And if the paths are too long to actually fit the packets together, you can temporarily bind a content address name and send it that way. So even we can always fit this into, the de facto 1500 byte MTU. Well, so IP is like variably sized and all this stuff, and the minimum size is formally like 68 bytes or something, and the maximum is, it might be 4 gig. There's like jumbo grams in IPv6 or something. But it's all totally fake because it all goes over Ethernet, and an Ethernet frame is 1,500 bytes. And so the MTU, the maximum transmission unit of the internet, is 1,500 bytes. And anybody who tells you anything else is lying to you. So your packet has to fit in that. And we have to fit a lot of data in these packets, right? This is the downside of this progression that Van Jacobson is talking about, from data being implicit in the topology or the connection to explicit in the data, is that you've added overhead. You have addresses. You have a lot of overhead here. We've got paths, we've got signatures, we've got hashes, right? When we're sticking two together, we have a path for the acknowledgement and a path for the payload and a signature for the payload and the data of the payload. The fragment payload is always going to be exactly, no more than 1 kilobyte. We need to have a model that lets us fit a whole kilobyte in there, that lets us index into the message in a very dumb, stateless way. We don't want to have some kind of sliding window there. So if it's too big to literally fit the packets together, right? Just take the payload, rebind it under a short name. Say the name of it is, it's just a hash, right? And you can tombstone that anytime you delete it away, a request for that won't resolve, and you fit it back in. It's done. It's fine.
Got it. Thanks.
Any other questions? No? Let's give it up for Master Morzad, everybody. So, we will take a quick 5-minute break and get set up for the next speaker. You guys can go to the bathroom, grab a drink. Be back soon. Thank you.
Oh, I should probably set up the slides.
Oh yeah.
It'll be useful, yeah. I was focused on quitting everything.
Okay, and we're back. So thank you everybody for being so attentive on day 2. We're almost done. We have 2 more presentations, and this one sounds like a really fun one. It's called Odyssey, Reimagining MMO Architecture on Mars, presented by Littel Wolfer. Everybody, round of applause.
All right, so this is going to be pretty much the opposite of Joe's talk. I think it was good that I went after him because most of what I'm going to talk about is probably like really the reason why this doesn't work, having Urbit MMOs. And that's because networking on Urbit is kind of difficult. And the only reason why I'm attempting it is that I don't really know anything about Urbit's networking. It's kind of nice to be, sort of naive about this stuff sometimes because you can find some interesting things. And so what I've been doing for the past 3 years is building this sort of MMO that already exists, right? It is a old Korean style MMO. And it was, I guess, decompiled, or someone stole the code base, right? And people started running private servers. And those private servers have been running for almost 10 to 12 years. There's a few of them that are more populous than the actual official servers. And so I tried to port this to Urbit. And so I started when I I wasn't very good at writing Hoon. I'm still not very good at writing Hoon. But I think now it's finally come to the point where I can actually release it soon. And so this is kind of just an overview of everything that I've done so far, how I approached it, and what I would do differently. So I'm calling SSO RPGs are small and shitty online role-playing games. This is kind of what I think Urbit games are going to be like for a long time. Maybe not the shitty part, but at least the small part. I think there is a lot that makes the massively multiplayer aspect of video games not as interesting on Urbit because you kind of get to curate your own sort of small community. And we've seen that in most groups, right? There are a few groups that I'm in that I really like that don't have very active conversations, right? Maybe once or twice a week there's a thread that's 20 messages long, and that's it. This is kind of a sign that your community is going down the tubes on most other Web 2 platforms. But on Urbit, it's we have this sort of confidence that this is going to stick around, and so you're okay with just having a small user base, even if it's just a chat room, right? So I kind of want to turn that into where you can hang out on, in a capital city in some random MMO, right? I don't know if any of you guys played WoW, but in WoW, people used to sit in on the Orgrimmar bank and just chill there. And if you had really cool armor, everyone would think you're sick. And then you'd get into guilds and you'd make friends. And one of the things that I used to play EVE Online. And EVE Online had it was basically an Excel spreadsheet, but as a game. I basically watch a ship just mine an asteroid for hours when I was a kid, and just calculate the rate of how much iron I was getting. And then I just get robbed by pirates when I went to Joda. And so I think like that sort of, I really enjoyed getting robbed because it was, it was just like so, I mean, I hated it at the time. Like I was really upset. And it was like thousands of dollars worth of time and actual like virtual items. You could buy these like time subscriptions, right? So, and they were an actual item, like it was a monthly fee, right? The actual item in the game was a thing you would cash in to keep playing the game, but you could get robbed. You literally get robbed of your ability to play the game. But this was all managed by a big corporation that actually did it really well, probably the best MMO gaming corporation there is. They have a really, I think they have 20, 30,000 people on a single server. They have a really interesting server architecture. But at the end of the day, it's still a really big centralized game that just falls apart the minute you want to like do something custom, right? You have to kind of follow these set routes that either the community or the devs prescribe for you. So by being small and shitty, you can kind of subvert that a bit. Because I think with Urbit, you know, you have a lot of people who are okay with building apps that just kind of suck, but they're really like, I'm not looking at you, Palfun. Yours are amazing. I'm looking at myself, really. I just ripped off Palfun's Pals app once and just turned it into a fart app. When all you would do is you would send, you know, friend requests to other people, and it would just play a fart sound. That was the only difference between my app and Pals. Except it also stored a big fart MP3 in your loom. So everyone who downloaded this app has a giant fart in their loom. So. Okay, so motivation behind these things. This is actually serious here. I think that there are really interesting ways in which Urbit's networking stack can enable fundamental innovations. One of those ways is the transfer of servers across like time, basically, in that like if a company stops supporting a game, ideally they haven't monetized that game as like, oh, I'm selling it like a disc. It's more like you're selling this sort of experience that you have a renderer for, and that renderer can be switched in and out. And so the way that I did this with Odyssey, which is the Ragnarok thing that I'm building, is that I have kind of two versions of it. One is the browser version, that's just the old client, the old Ragnarok client, same as the old game. And the other is a text-based like CLI entry point into it. And so you can do a limited amount of things on the CLI, but those things are reflected in both worlds, right? So like, it's kind of like as if you had like a bot for an MMO, right? If you run that bot, like you kind of are playing the game in some sense. You have a different interface into it. Most bots don't have like the actual graphical interface. They just have like a stream of logs telling you what it's doing. One of the interesting parts about Ragnarok was that it's all packet-based. So that means like you would just send packets over a TCP socket, and that would influence the game. That's how you moved, that's how you attacked, that's how you did anything. They used to not encrypt them early on, and so when everyone would just figure out what packets meant what, and then just write scripts to sort of either bring down the whole server, or just grind on, like there was these plants that you could just hit over and over and get herbs out of, and people would just write scripts to do that. And so I think this is actually very fun. And I think that there are people who want to build the sort of theme park video games where you just have a really prescribed route that you take, and if you deviate from that route, it's just it feels off. It feels like you're sort of not watching the same movie anymore, and that feels weird when it's built like that. But whenever I play games, I kind of wanted to do exactly that, where I wanted to see where like the weird glitches are, right? Where if you kept walking, past the boundary line, like everything would look weird, and you could see how the mountains were rendered, and you wouldn't render the part below like a certain like distance because you knew that no one would ever be able to see that. And so having MMO sort of like base framework MMO architecture on Urbit will be really nice because you kind of offload the renderer to other developers, right? And I feel like this is kind of a strategy that many Urbiters kind of take now, is like they build a thing that maybe they have a minimal UI for, but it kind of exposes a protocol that people can use to enhance like their own experience on Urbit. Like PalFun's auto thing yesterday. Like you can basically write bots now. If we have a gaming framework on Urbit, you can respond to like specific maybe friend requests on pals and have that like reflect in game. Like I don't know, maybe you friend them in game. Maybe it actually hooks up to pals directly, right? Like there are tons of different things you can do here. That like just having a traditional renderer, which is kind of what I'm calling like the client of a video game, being able to render these Urbit native things there would be really, really nice. So there's also the aspect of security and privacy, but this is not real, right? Like there's not a lot of security and not a lot of privacy on Urbit beyond what you like give yourself. And I think that's kind of the bigger point here, is that running your own server kind of forces you to think about things you wouldn't think about if you just were logging into, Blizzard's battle.net every day and saying whatever you want on their chat. I'm sure there are many people here who have gotten banned doing exactly that. And I am one of those people. So yeah, direct peer-to-peer communication and eventual sharding. I think this is really interesting because one of the annoying things about MMOs would be you would have to like when some big event happens in game and the server limits start getting hit, you can't do what you wanted to play the game to do, right? You have to basically either wait in a queue or just go to bed or something. And it sucked because it's like this is a game that you paid for and now you can't play it. On Urbit, like there's this opportunity to just play locally, right? Like kind of turning these MMO experiences into like basically LAN parties is a much more interesting thing to me. And you don't have to depend on these giant servers that have to serve thousands of customers. But again, this can't happen without an actual game, right? So this can't happen without an actual game, right? You don't own anything if there's not anything to experience it with, right? And so this is the problem with NFTs right now, is that everyone wants a game, no one can actually build one. And so these are some of the things that I've wanted to build for a while. Some people have already started building them. Like there is a chess app, there's a Go app, but there's no turn-based strategy games yet. Vaporware is actually one of the only people building like games right now for ulterior motives, I guess. But it's still a game and it's still fun. So this is it was interesting. I joined Vaporware like before I decided to, or after I decided to do this talk, and I didn't know that they were building a game. I just thought they were building, sort of NFT marketplaces to, I don't know, try to get a lot of money into Urbit or something. Sounded cool, but like I didn't know it was like anything more than that. It turns out that like the market mechanics, like social mechanics of Urbit are really amenable to the sort of things we don't like about NFTs, right? Like the shilling of NFTs that I was very guilty of at Assembly 2021. It becomes like a much more interesting prospect when the things that you're shilling have actual consequence on the network that you spend all of your time on, right? And so all of these games here, they can all be augmented by the things that you do both on chain and on Urbit. So even just the simple existence of like a couple of old Goras could mean that your character in one server just has like OP stats and you can just murder everyone in Frontera or whatever, right? Like there's these very real consequences of being like really active on the network now that I think a game will just sort of blow up, right? So problems. Good games are hard to build. I think everyone knows this, but I think the second point is more salient. Everyone wants these like really, really nice AAA graphics games, and if you ship them a Pong, they're not going to play it, right? This is what people think. I actually think it's not true if you have a really, really good game, right? So a good example of this is the Ragnarok stuff, right? There's a reason why people still play this game in 2023 when it was released 23 years ago, and that's because there's an actual like social dynamic that it sort of enables, and a like pleasurable grinding experience, which I don't think I can't really put that into words, and people probably think I'm crazy right now, but like there's like the idea of just like Korean experience grinding, gold grinding was like pretty much what gave me my work ethic. So I would just sit there and like just swing away at orcs in a dungeon for 6-7 hours, and it was really easy to go from that to just like programming for longer, right? This is how I kind of treat programming. It's why a lot of my code is super messy, because it's just brute force, right? Like there's this really like stupid way I go about building stuff that I think actually allows me to like get to places that I think most smart people wouldn't get to, because they're just like, what the hell? Why would I ever try that? So this is a good example of it. Let me see if, yeah. This is my solution to the MMO problem on Urbit. It's shameless knavery. And so I call the style of programming that I've been using to build this parasitic programming. And that's because I do exactly the opposite of what Joe would probably want me to do. And that's I have a tiny Mars agent, tiny Gaul agent that runs next to, on the same server as just a standard game server, right? Like the one that runs Ragnarok is C++, and it's really fast. Since it was made in the early 2000s, it's still just like parsing packets and doesn't have any logic that's very complicated. It still just like indexes into the bytes of the packet. It has giant if statements that just fill the screen. It has macros that only run certain code based on the packet version, which is versioned by like the literal date of the release of that version of the game. And it's just huge trees of this, right? But it's simple, and you can actually build against it without wanting to kill yourself. So this is sort of like a generic example of what you could do if you wanted to do something similar. And it's not complicated. Literally, you just hijack whatever thing that you want to have on Urbit. Another example that I did recently was with GatherTown. I just used Selenium to pull in the chat logs of the Gather room, right? And I filtered it for whoever was DMing, like a bot that I had put in there. And then that bot was responding, Selenium was then sending requests to the Urbit planet associated with that bot. So that would be like the client, right? And then it would play music based on what command you gave it, right? So this was like the Spotify client that I made a while back. And I got that working on Gather by just doing something similar. It's not ideal. I don't like want to do this in the future, but I feel like a lot of Urbiters kind of forget what is possible, what like we actually want to do, and we end up just like complaining about what Urbit can't do. But actually, it can do a lot of these things. You just have to be gross and dirty for a little bit. So yeah, stage 2 would be this took me about like 6 months, and then I implemented graph store integration into the Ragnarok client like about a month before App Store disappeared. So that was really fun. But like, yeah, you can do this, right? Like, it's really interesting to communicate with people on Urbit on a client that wasn't built for Urbit. So like everyone's used to doing things on, landscape, right? There's pretty much landscape or the dojo are the only things that people really know. But I don't know if anyone remembers, I did this Emacs thing like a while back where I had a whole landscape clone in Emacs. And so I could like split windows, I could copy text, right? Like, I know it's crazy, you can actually copy text in Emacs, and I guess browsers just are bad at it, I don't know. But yeah, so it was, there's a real like way in which you can be on Urbit and have it be your own thing. And I just feel like people should try it more. People should try to like bring something from Earth into Urbit and see what happens. So this was another thing I did. So building simple sale pages, right, HTML pages, as clones of, like sort of static clones of the state of your game. And then having those static clones sort of be an element of the game itself from the other side, right? So you can have things like, like a marketplace, right, that you can see on your Urbit planet. And then if someone buys something there, it would reflect in game, and you can basically like build out a sort of 2D version of the game that you can play like on your phone. This is something that like people in like the traditional gaming world try to do all the time, and it takes them a long time, and they usually fail because it's you can't just pull in data that exists in a good state, right? Like, this is what's nice about Urbit is the minute you define your structures, you can use them across many different apps. And those apps don't have to be anywhere near the same as the ones that were originally defining them. And so, like, pals could easily be something completely different. It could be foes, right? And but it could still use the exact same protocol. So yeah, and then finally, you would want to actually write the game logic in the server. So this is where Odyssey is now. It's right. I already kind of went over a lot of this. Yeah, there's two agents. There's a server agent called Odyssey, and then there's another called Midgard. The Midgard desk ships an actual like full, really large front end to you. I'm doing it with S3 now because I don't want to brick your aims. But maybe when I can send big nouns over the network, I will. And so this is literally just a renderer. So I have a generic description of the how the game should look, as much as I've been able to pull from literally playing the game. This is sort of like like dog fooding the actual rendering logic. Is I just play the game until I see something that like I could represent on Urbit, and then I pull that into Urbit and update it whenever it updates on the server side, right? And so there's many things that this doesn't work well for, right? You don't want to update every single move on Urbit. I don't think it would even be possible. But it's nice to store, say, every open item shop in every city, right? Because then you can represent those things outside of the game and then attach them to stuff like NFTs. So this is how you get really quickly a full like NFT game without ever really meaning to. And it doesn't have to be based around like these weird financial economics of NFTs. It can just be a game with NFTs that you can buy. And so you don't have to have like these microtransactions. You can have peer-to-peer transactions that yes might not make like the company that built the game very much money, but the company that builds these sorts of games should not be making much money anyway, because they should be really simple. And you should let the people who play them build the rest of it. So yeah, this is kind of like a overview of the stages that I went through doing this. I originally had it directly inserting into a MySQL database and that I was running a REST server in front of so that I could communicate with it over HTTP, because that's all I knew how to use Urbit as like a sort of Earth communication agent. Stage 3, this is the most interesting thing. This is something that I wanted to demo today, but I couldn't get the new binary compiling. But LIC is a very interesting protocol that allows you to just send mark and nouns pages over a socket, a Unix socket. And like I said, this Ragnarok Online was a packet-based game. So if I could just redefine or define the packets in Urbit, which is really easy because Urbit is really good at byte manipulation. And so if I want to parse these packets into like small little bits with all the information about what is changing in the game, it's almost trivial to do this on Urbit and really, really annoying to do in like C++. And so I started defining the packets that I wanted to basically have the server use as a communication pattern, and started looking exactly like sending agents to, or sending moves to an agent. And so this is how I kind of started thinking about like this sort of parasitic development thing, is that anytime you can get something looking like just a black box that you send events to that changes and then responds back, you can pretty much bring that into Urbit, and it kind of naturally falls into place. So yeah, this is when I'm going to release it. I'm going to have user scripting in Hoon and game logic in Hoon, which means you should be able to write plugins with it. And so you can write your own games with this library. You can write your own servers with this library. You don't have to use the server that I'm using. You can just use the sort of game definitions and change what you need. Yeah. So yeah, this is something that I really want, because I feel like this will be the next big thing. Because I basically have all these rendering definitions, but no way to render them, and they're also probably the wrong rendering definitions. So I'd like to use the right ones, and that's probably Goon. But I don't know where Liam is. So this was another thing I was thinking about, a sprite-based 2D rendering engine. I think we need, well, 2D rendering is not that hard, so we might not need like any vector math for this. But I don't know what the status of the vector library is in Urbit. Is it still a PR? I don't know. Do you know?
We're working on it.
Yeah?
Yes.
Awesome. Once that happens, I feel like we can actually start doing some of this logic. And I think we'll quickly come, we'll quickly see limitations, right? Because Urbit is slow. But it's nice to push on those things and see what you can do with some of the slowness. Yeah, development of cross-game universes. This is kind of what I talked about already. I think that there's quite a bit. One of the reasons why no one is trying to hack Urbit, I think, is that no one has any money in Urbit, and no one wants to put their money into Urbit. But I think that if you try to generate game value on Urbit, and sort of build these sort of fake economies, people end up turning them real eventually, and then things actually become valuable. And then people will want to hack us. I think that's a good state to be in. I feel like we need to prove that we're not, like, we're a valuable project to try to hack. It's really boring where it's like everything is open and no one's trying to steal my stuff. It's like we've had software distribution for 2 years now, and I still haven't, like, nothing bad has happened, and that's terrible. Yeah. Exactly, yeah, we need more PvP. So yeah, the last thing is every group becomes a guild on this game, and so all of the biggest groups will de facto own all the guild castles in Ragnarok, which means that once this is released, you'll have to defend them. Otherwise, you lose your Rune Knight status. So, Zorp. Okay, that's it. Any questions?
How do I play it? Where's my button?
So it's just going to be like you install it on your ship. it'll be an S3 link that you'll have to, I mean, it'll probably just be a glob, actually. And then I'll probably tombstone it. But yeah, so it's just a browser game. I have to be running the server though. So until I can make it completely decentralized, there's going to be that component to it. But I'm also going to be shipping the server, so that probably for sale actually. But if you want, you can run your own server, and I'm using Lick to actually coordinate the bringing it up. So kind of like a Nix, a really shitty Nix through Urbit, which you can actually do this because Urbit is Nix according to Hacker News. So.
What does Ares mean to you?
I mean, it would make this possible, right? I mean, it would turn the small and shitty into massive and multiplayer. But I think it's nice to start somewhere, and I think there's no reason why we can't get a head start on some of this stuff. I think this is what all of us at Urbit have been doing for a while now, and we can kind of like talk about it a little bit more and be a little bit like more confident that this stuff will actually help later, rather than just be rewritten underneath us in a couple years. But it still might. I don't know.
So Lick is the vein formerly known as Lock, right? That Mopful Winterx is working on. Would that also allow you to like draw things directly on the screen?
Yeah. So I was thinking about that too. And this was what got me thinking about the 2D sprite renderer. I think that would be the easiest first step. It would be really cool to like have basically like a Twitch stream style thing where you could look at Urbit traffic and then just like render stuff on some sort of stream that you just subscribe to, and every person who plays the game has like they generate entropy that then gets written to some, and then that input could then be used or that output could be used as input into the game, and then it becomes like a randomization mechanic. Like using the Urbit network as sort of this way of basically building content from the randomness almost, I think is one of the most fascinating things we could do.
Something that's like occurred to me before is maybe like apropos both like the rendering engine and but also kind of like maybe like physics and so on, right? Is that obviously you don't want to have a physics engine running in the event loop.
Why not?
But so I mean, with respect to like Go native UI, I mean, like a large part of it is kind of certain stuff can be sort of like dynamically sort of like rendered. You're specifying like a sort of scribe path, but also include like sort of like range query, and so it's not necessarily necessary that like a state change would necessarily need you to like write out a new like goon tree.
Yeah.
Like, I mean, is the sort of rendering that you have maybe like that you've thought about that kind of like similar to that? So and like a similar thing would be kind of like.
I mean, because it's Urbit, it's like I'm always trying to namespace everything. So the renderer is a tree. It's based off of one of Liam's old goon things. I'm not sure if he's still using that model or not. But it's just a tree. I'm using Sail to render it right now. And you kind of just have, it only works for certain parts of the game. And so there are small parts that, so for example, you can sell items. And the way you sell items is that you have to have a character in the game that spawns a shop. And then you have to stay in game. And so I just kind of hijacked that, and you still have to stay in game, but you're in game as this like Sail render, right? And that Sail render you can interact with both in the game as the normal way that that whole part was built, but you can also interact with it on like a landscape channel almost, where you have like basically your sort of shop, right? And you can like choose items from your inventory and move them back and forth, and it's like this really like 2D style way of rendering what is also being rendered at the same time on the server, right? And so these like sort of slow things are the things I'm doing first, right? Like the things that don't need you don't need to worry about timing with starting a shop, right? You do need to worry about it if you're like, trying to beat a boss in a dungeon. So I'm not going to try and render that in Sail or something, but eventually.
Yeah. Like it's kind of like for the if you can for like the more sort of fast things, like declaratively kind of like sort of specify it, and then it's just like it doesn't change, right?
It's kind of like React, right? But like in a good way, where it's like you just have this huge namespace, right? That you can jump to. Like I think I was talking to Ted recently about one of these. Like there's this idea of having a coin in your path, right? And that coin is basically has like a rendering, a part that can be rendered as like basically a symlink into somewhere else in the tree. And so you can really build some interesting like fight scenes with that, right? Where it's like like just ASCII fight scenes, right, in the dojo, where you just have this huge namespace that you're just updating. Like maybe there's a huge like guild war going on, right? And you can see that guild war happening like in a separate session in dojo as this like huge tree of different pieces updating as people get killed or cast certain spells or win or lose.
Yeah, I was wondering if you could talk more about like what's on your wish list for networking.
Everything that Joe talked about. Like he's basically building like the kernel level stuff that I'm trying to like stupidly build in user space. Like the whole. I mean, it's obviously more complicated, and there's concerns that like I don't have to care about from like a user space perspective. But like the whole idea of everything that's being done with aims is very similar to like how I want to update things in user space. Like there are like the idea of not having to do things twice, right? The sort of like connection based thing you have to build when working with traditional games is really difficult to mirror in Urbit, and I think that's a good thing because it makes you rethink the entire game and have to like redefine your like the SIR file that corresponds to like that Web 2 version, which basically just gives you a new game. I think that these like starting from old games is really fun because you could see this like kernel of an idea that they had about how to build games that has been like completely lost now, and so yeah, I think just having like listening to Joe talk about like how like the history of all this stuff, really like that's how I've been thinking about building games is going back to Ultima Online to MUDs and just thinking about how we can bring those into the new world without like just copying them, right? Like I don't want the same exact game. I want like the Urbit experience of playing this game. I think it would just be better because you retain your state, right? So I can just shut down my Urbit at any point and boot it back up, and I have that same game with the same saves, the same stats, and even possibly even like a bifurcated tree that like where I don't have to listen to what the server is telling me I have to update to, right? Like if I like say a specific version of a specific class, right, that I liked playing, like say I really liked playing a monk or something, and then they nerf it in like an update. Like I don't have to update to that. This is like one of the greatest things about Urbit. You can just say, don't give me any more aims packets. Yeah, I don't think that really answered your question, but.
Any other questions? Let's give it up for a little Wolf. Amazing. Thank you so much.
Can you just pull that out? Thank you.
So we're gonna mic up our last presenter for the day, and again, thank you all for being here, being a part of Reassembly. We really appreciate all the attention and your time. So just give us a couple of minutes, and we will hear from Zorp, the Zorp ZK VM. Thank you. Okay, so last but not least, we will be hearing and learning about Zorp, the Knock ZK VM from Logan of Zorp. Everybody, round of applause.
All right. Let's see. Can everybody hear me? All right. Sounds like I'm mic'd up. Okay, so I'm Logan from Zorp. Zorp's big old team now. I think we're at 10 now. We are a Knock company, and we're building the world's best general purpose, verifiable virtual machine. Okay, so let's break that down a little bit, because all of those words mean something, right? So everybody here knows that you can do general purpose computation with Urbit and with Knock. You can do things like networking. You can do things like building games, like we just saw from Jake. You can do things like building collaborative document editing. You can build chat. You can build gossiping rumors applications. You can build friends lists. You can build persistence. You can build build systems. You can build arbitrary system computation, arbitrary user space computation. We all know that. A lot of people, well, they work with languages that aren't as general purpose as ours. And so it's really, really worth kind of nailing down specifically what we're up to over here with Knock, all of us together. Okay, so Zorp has made Knock not just a really strong general purpose virtual machine that could realistically one day run on your phone and your server and your laptop, your blockchain, your whole deal. But Zorp has now made Knock verifiable using zero-knowledge proofs. So Zorp has made it possible now for us to take this general-purpose virtual machine, not some, say, you see a lot of ZK companies today that make blockchain-specific ZK VMs, like, say, Cairo as an example. People that are building languages that are very specific to just the purpose of doing verifiable, provable computation. What we're doing is quite different than that, and there's really only one or two other people that are even doing anything remotely similar, which is we're building general purpose verifiable virtual machines, or the ability to take anything, any computation, in any context. Now, of course, it would need to be targeted towards Knock and make it verifiable. And by verifiable, what I mean is that you don't have to trust it. You can very, very succinctly, simply, quickly verify that a particular computation was done with some particular input and received some particular output with very, very little work to do the verification, very, very little data that needed to be transmitted in order to do it, and absolutely no trust. So, I know we're all Knock partisans here, and this is a little bit of why we're here. I know many people are also Urbit partisans even more than they are Knock partisans. But we strongly believe at Zorp that Knock is the perfect VM for ZK, blockchain, and everything else. We think that Urbit is this everything else, more or less. And we think that that's wonderful. So Knock is perfect not just because it's small, not just because it's minimal, not just because it's built on binary trees. Knock is perfect because it's highly structured. It's a homoiconic pico-Lisp built on a single data structure, which is able to efficiently and succinctly build Turing-complete computation without throwing you into the hell that is lambda calculus. Okay, so we don't want to be in lambda calculus hell, but we want to actually understand what our computers are doing. Okay, so the claim with Knock is that the way to understand what the computer is doing is not by building more and more complex abstractions, but rather by simplifying the base layers down to a level that can act as a specification for what should be happening that is actually cognizable, that a single person can then inspect and understand. And so we strongly believe in being able to understand what's happening. So in that vein, we're going to get a little bit in depth into how our ZK proofs work today. And then we can go a little bit even more into what's so awesome about us, which is, well, Wow, this is going all over the place. Okay, so similarly, I'll give you a little bit more on knock, and then we'll get into the juicy stuff. So what we see in the ZK space in general is, well, there's a hell of a lot of people trying to build ZK VMs, et cetera, but most of them really aren't that good in various ways. And so what we find is that we have maximum expressivity in knock and hoon. And by that, I more or less mean maximum developer productivity when working with the language, because it's extremely expressive and easy to work with. We also have maximum efficiency, and I'm going to get to why that's the case, because that's a large part of what this talk is going to focus on. But we also have maximum generality. In other words, the language we're working on, I've already hit upon this, is really, really good for a variety of contexts. It's not just some tiny little domain-specific language that's only good if you're doing ZK. It's not only good if you're wanting to do blockchain stuff. It's not only good for smart contracts. It's not only good for Urbit. It's just really good. And so in this little schema of generality, efficiency, and expressivity, knock is maxed out in every degree. And everybody else is lacking in some dimension or another. So getting into some of the juicy bits of, well, what makes knock unique in a ZK context? Well, the high-level answer is that we've liberated ZK VMs from the von Neumann style. This is a little bit of a play on a paper that some of you may recognize. But the point here, the thing that's interesting about this, is that knock is a pure function. It's a pure function with a single data structure. And not only is it a pure function with a single data structure, but it's a pure function where every single transform from one data structure to another, or one state to another, is a cognizable step from a single data format, which is really, really beautiful, but also that all of these operations reduce down to a very, very easy to model operation, which is concatenation. Trees and other Lisps, but trees particularly, get really performant concatenation, because almost anything that you want to do is going to reduce to log n time. So this provides us a bunch of wins, and we're going to go look at many of them. But I'm going to give you the payload to start with before we get into the dense stuff. And to start with, memory editing, really great. Memory retrieval, really, really great. Deduplication of reused memory objects across the computation. We can do it automatically on the back end. Easy ability to decompose and destructure operands without needing to resort to really expensive things like, say, Merkle trees. We get it. Many other different traits here we can get in very, very powerful ways. And we get to represent the abstractions that knock is using and the invariance that knock needs to maintain across the computation with extraordinarily minimal primitives. I don't know if any of you have interacted with any ZK research papers, but they're dense. It's not always a bad thing. A lot of them are really, really, there's a lot going on. But, well, I mean, necessity is the mother of invention, yeah? I mean, if you're trying to fit a square peg through a round hole, you're going to need to invent some really freaky math if you want to be able to do anything with it. We're in a lovely situation where we've actually been able to get best-in-class results with very simple primitives without even doing these more complicated transforms, which we're now in the process of implementing. Okay. So let's talk a little bit about binary trees. Can someone move this picture of me over there, or get rid of it? I don't care. Okay. All right, so we've got a binary tree, right? This should be fairly recognizable to many of you, right? We've got something on the left. We've got some stuff on the right. Turns out that we don't need to represent this in the naive way that we might be inclined to, or that we might be used to veer representing this. We don't need to represent this binary tree as a series of pointers. The naive way to handle this is to say, okay, this is our state. This is going to have a pointer to this. This will be a direct atom. This will have a pointer to this, which will have a pointer to this, which is a direct atom, pointer to this, pointer to this, direct atom, pointer to this, direct atom. Veer is able to do some tricks with this to make this not horrific, which is it's able to do a bunch of deduplication so that at the very least you don't need to store many, many copies of some of the same like large atoms or things like this. But there are things that we can do in a ZK context that are far more efficient than dealing with pointers. which are to reduce this structure down to a pair of vectors. Now you can also do this natively in Vir if you want to, and it's actually really, really useful in some contexts, and I expect that Aries will at some point implement perhaps this strategy, perhaps a similar strategy for some data structures, probably with some intelligent analysis around when to do it and when not to do it. You might imagine it, if you're kind of an interpreter guy, as being somewhat akin to vlists, but really, really generic. Okay, so we're able to separate this binary tree structure instead of having to represent the links between the different nodes explicitly with pointers. We're able to separate it into a shape vector and a leaf vector, right? So let's start with the leaf vector because it's super obvious. We can see that the leaf vector is a depth-first traversal of the tree. You have your 0 on the left, then you go down to the right, then you go left, left, now you're 6, up, right, 20, up, right, 1. Okay, so the shape vector's a little bit more involved, but not too bad. So the shape vector is built on a recursive relationship found in combinatorics called dequards. And so that's wonderful because you can actually build this up also with a depth-first traversal of the shape of the tree. So let's kind of examine the left-hand side. With the left-hand side, we have an atom. In a dequard context, that's empty. You don't need to put anything there. So we slap a 0, an empty, and a 1 to say we're going to cons something. And then we just start expressing the right-hand side. So the right-hand side, we go left, 0, we go left, 0. We close with a 1 because 20 and 6 are atoms. So we say 1, then we go up, and then we say 1 again. So at a high level, this 0, 0, 1, 1 represents the right-hand tree structure, and the left-hand tree structure is represented by an empty, but because it's concatenated to the right-hand side, you have a 0 and a 1. Okay, so a little bit more involved, but there's a recursive relationship. You can always build up more valid dequards just by consing existing valid dequards to them, with the caveat that you need to put a 0, then the left-hand side, a 1, then the right-hand side. But still, really, really simple cons relation. We're going to get to this. Okay, so the first transform we did was we turned our binary tree into this pair of vectors. The second transform that we're going to do is we're going to express the length of the number of leaves. We're going to express the shape, and we're going to express the leaf in terms of finite field arithmetic. Okay, so we're going to pretend that instead of this being a vector, it's actually a polynomial. And I'm not actually transforming anything, I'm just saying let's think about it a little bit differently instead, right? So if you look at this, you can say, okay, well, if you kind of start from the bottom, you can see there's a 1, okay, there's a 1, so 1 plus x, right? And then there's a 0, so that would be x squared, so 0x squared, 0x cubed, then we get 1x to the 4th, and then 0x to the 5th. Okay, so that's our polynomial that represents the shape vector. Similarly, we have a leaf vector. This one's obvious. Okay, so now we've got a polynomial represented in a finite field. Okay, and these polynomials in this tuple at this point, we've got a kind of a 3 tuple, at this point represents our binary tree. Okay, let's keep going. So now we have some funny tricks that we can pull. Which is that we can evaluate each of these polynomials. Note that length is kind of a trivial, it's a constant. But we can evaluate the other two using Horner's method, just a standard, let's just go evaluate our polynomial, like let's go plug in some, like a value into it and go evaluate it on a random value. Now, in an interactive Oracle proof, that random value is actually generated by a hash function of all the data that you passed into it using what's called the Fiat-Shamir transform. But if you're kind of modeling it outside of the random Oracle model, you could imagine you could actually pass in any random value and be able to get a fingerprint of these, from these polynomials. Okay, so we're going to take these polynomials and we're actually going to evaluate them on random elements, which is going to be, in our case, alpha 1 and alpha 2. To break this equation down a little bit for you, we essentially have our lambda term here, which is just representing our length, which is on the left-hand side. Then we have our center term, which is our deep felt or our deep word. So this W is the term, right? So we know that we have a function of the length in terms of the number of terms we have. And so we can sum up the individual terms evaluated on the randomness at the appropriate exponents. Similarly, we can do the exact same thing for the leaf vector. And so, in other words, this is just plugging in alpha 1 and alpha 2 into the first and second equations. Okay, super simple. This gives us fingerprints, but we still have a 3-tuple. Okay, so now we can actually take this 3-tuple, which we call our interactive oracle noun fingerprint, and we can then do tuple compression if we want to treat it as a single value. We don't always do tuple compression. I'm just showing you a technique that we use often if we want to have, say, a single value that's representative of a binary tree. So you can use this, and this is very simple. You have new randomness, A, B, and C, and you have length times A plus shape times B plus leaf times C. Now the key here is that the randomness, in our case, is deterministically generated based on the data you've committed to. If that wasn't the case, in other words, if you had not committed to all of your data, you might have degrees of freedom to be able to pick randomness that might allow you to forge results. But because you've actually already committed to all of the binary trees that could possibly go into your computation and the order that they occurred, and you committed to a bunch of things, and I know I'm kind of bleeding in details of the actual invariance of Nock, so we can get to how we use some of these primitives around binary trees with Nock in a minute. But at a high level, if you commit to everything you need, then you can use these random values to get secure fingerprints and secure compression of these different components into a form that you can actually non-deterministically retrieve out the pieces. So this gets to something that's quite funky. We'll probably get to it later, and I'll just back up through the presentation. But at a high level, we can take the 3-tuple and we can compress it into one element, one finite field element, and pass it around instead of needing, say, a pointer to the data within our VM. Okay, so, and as we all know with Nock, cons rules everything around me. So many of you, and stop me if you don't, please somebody raise your hand if you're not familiar with this, are familiar with hash consing as an interpreter. Okay, not familiar with hash consing. Okay, great. So hash consing is a common technique used in Lisp interpreters to more or less be able to do very cheap deduplication across a memory arena, or often to be able to kind of compose operations lazily, as an example, that you might not necessarily want to do in place. So you can say, okay, we're going to do this operation, but we're not going to yet. Or you can say we're going to globally deduplicate items. We recognize this hash, so we don't need to store another copy of it. We're just going to store a pointer to this other one. Okay, so hash consing is a pretty common technique that's actually used in ZK VMs regardless of whether they're binary tree based, because Myrtle trees are a very convenient and dumb and simple way to commit to structured data. And so often, even if they have kind of a regular old AST, they'll Myrtleize it and they'll turn it into a mast. However, every time they want to go decode an instruction, they need to go eat a ton of hash verifications inside their ZK VM, which is extraordinarily inefficient. Now, hashing's not that inefficient in a normal context, but in a ZK VM, it's terrible, because the whole point of a hash function is that it's hard to calculate. And so, I mean, that's not the whole point. It's also collision resistant, blah, blah, blah. But often the way you receive collision resistance is by having complicated structures like S-boxes and other things that, at a high level, require you to have multiple rounds of arithmetic operations being performed on something. And, well, this is expensive. There are ways to speed it up, but you can't get around the fact that doing things that are more expensive in an arithmetic machine is going to be more expensive. And so everybody else destructures data using Myrtle trees, or even worse techniques, to be honest. Like just saying, well, do we really care about succinctness? We're just going to have all our memory be public. You can just see all the memory at every point. You can just go query it. Okay. So let's kind of go into things a little further. So because we have this beautiful relationship right here and here, where we're able to represent any individual tree as a sum that is based on its length as a polynomial. If I want to take another binary tree and slap it on, right, and cons this one to it, right, and form a new binary tree where, say, let's go back to the very beginning. If I want to take a new binary tree, let's say it's the same one. What if I want to slap another one of these trees on this one? So this one's the left-hand side now, and this one's also the right-hand side. If I want to do that, well, on the one hand, I've already talked to you guys about, well, what would it look like to do this? Well, we've got a valid deque word. We can put a 0 and a 1 on either side, and then just copy the inner body. Again, now we've got the shape, right? And then we can just copy 0621 and 0621, do it again. Okay, but how would we represent a verification of that? How would we verify that we had done that in a ZK VM context? So at a high level, instead of needing to do something like hash consing, we are able to do cons via exponentiation. So you notice how alpha 1 and alpha 2 here are being exponentiated based on the sequence, based on the sequence number through the polynomial. What we can do is we can exponentiate the left-hand side, and forgive me if I'm off by 1 or something, more or less by the length of the right-hand side. And then just be able to add them up. There you go. We just did cons by exponentiation. All we did is exponentiate, multiply that whole polynomial by the exponent factor one time. Then we did it again for this one, and then we just added them. That's extraordinarily cheap in a ZK VM. That's one multiplication, an exponentiation, which you can batch, and then an addition, which again is even cheaper. Okay, so this is, nobody else is doing this. This is nuts. So we're only able to do this because everything we interact with is a binary tree. We don't have anything that's not a binary tree. In fact, we hate things that aren't binary trees. Okay, so let's talk about just some cute examples. What are we able to do with this, right? What are we able to do with this? Well, we can't just prove little silly knock programs. We can actually performantly prove real Hoon that you can go compile against our standard library. And starting on, I think the hackathon starts August 28th. Starting on August 28th, you're going to be able to start building programs that compile against our standard library. We'll be releasing our standard library with a variety of utilities that you can go play with. And you can send off proofs to our prover, which will be running on the network with our crazy custom interpreter, which will keep modding to be able to do the things it needs to be able to do for everyone. So this is an example of Fibonacci in Hoon. It's pretty simple. You've got your function. It takes in, how many times are we going to calculate Fibonacci? We start with x and y, which are 0 and 1, just because that's the base case of the Fibonacci sequence. Then we have a loop starting with the bar hep. Then we have a base case, which is of course the what call, which says, well, if n is 0, if we're done calculating, just return x, and then we just recurse through the loop, adding x and y, modding y to be x, and then we just say, well, let's decrement our counter until we hit 0. Okay, so I'm just going to show you guys a little proof of this, but a little bit silly. But you can see this is the same program, right? You see this fib file up here that's been scried that we've printed. Okay, so we're going to slap that against our flib, which is our finite field standard library, where we build up similar definitions that you'd be used to in Hoon.Hoon, not precisely the same because it's built around finite field arithmetic as the base of the increment case rather than unsigned big int arithmetic as the base case. So not precisely the same. But then we essentially can say, let's go slap it against it, which lets us compile it and get a gate that we can run. And then we can actually run this against our FOC interpreter, which is our finite field knock interpreter. This is just a funny name. We're going to change it. And so we can see, hey, we're going to go calculate Fibonacci for 3, just as a small, tiny little case. And you can see we get some printouts from our ZK VM engine. It says, blah, blah, blah. We do all our tests. We compute various parts of this, and I can tell you about it if you want in the Q&A. Then we get a bunch of printouts. And then we say, wow, we got a proof out of the other end. And well, the left-hand side of this proof is the actual result. And the right-hand side is, of course, the big old proof data structure, which you can go verify. And so at a high level, you can see we've got these tar and tar. We can see HEP was 2, which is what we would expect from having done 0 plus 1, then 1 plus 1, et cetera. Or we did 0, we did 1, and then we did 1 plus 1. So that would be the third case. And then we can verify our proof. It says yes, and that's all good. And many of you will be able to do this in just a few days. And hopefully you can do things that are even more fun too. All right, well, that is where we're at. Thanks, y'all. I'm happy to take questions.
Question?
So in the thing that you just made at the very end there that verifies that the third Fibonacci number is 2, to what extent does that original Fibonacci gate lie in that object?
Does it what?
Or to what extent is that Fibonacci gate represented in the verifier?
Oh yeah, so it's in the proof stream. So it's linked to in the proof stream. So you've committed to that program, and you can go say, oh well, is the program that I'm thinking that was run the correct one? Or you can like obfuscate the result and then reveal it later. Okay. Similarly, you can do the same thing with the output. So yeah, it's in the proof stream.
You talk about deterministic randomness, and that hurts my brain. Can you explain, like, those concepts to me don't mesh.
Okay, so what you can do is you can simulate randomness. And by randomness, I'm not saying that it's like literal entropy. What I'm saying is that it's not predictable. If you have a strong hash function and you've hashed all of the inputs and you've committed to everything that went into your program, then you're not going to be able to predict the numbers that come out of it. And that's called the random oracle model if you want to like go like bash your head against the wall with it. I can bash my head against the wall with you.
Any other questions? Oh.
So given that you're using finite fields, if I'm doing some kind of computation with large atoms, I would need to change that or rewrite that?
So what we have is we have support for unsigned 32-bit arithmetic. And what we can do is we are actually in process this week of writing a library around being able to do big int arithmetic in terms of lists of unsigned 32-bit integers. So you would probably need to like mess with it a little bit, but you wouldn't need to do anything crazy.
Does this mean you can just like parse all of the L2 logs and just resurrect all L2 planets with this?
Does this mean that I can parse the L2
Because then you
logs?
only have to do it once, and then you just have a verifier for everyone, and then you can just bring them all back into L1.
Okay, so you could do this. You would likely need to be very clever in the transpilation step in Tiny.
Right.
And if you weren't very clever, then it wouldn't really mean much.
Right.
Because the semantics of the, well, so I'll tell you something that is very speculative and likely won't amount to anything, just to see if you like it. But Edward has been talking to us this week about the possibility of actually simulating regular old knock inside of our ZK VM. You could imagine running a regular old mink using our big int arithmetic library and actually having increment implemented in terms of our U32 big int chunk library. You could imagine this. Now, whether this would make any sense to do, I'm a little skeptical personally, but you could imagine it as a way to do this without needing to be really clever with the transpiler and just take something like that already exists and do it. Yeah.
Could you give an example of how you might pass around proofs, like sort of in a little bit more of a practical, like how would you consume this into maybe a really basic app? Who do I give the proof to? Yeah.
Sure. So let's say that you and I both lock up 1 Bitcoin. Or let's say we do it on ETH or something silly, like wrapped Bitcoin, right? And so let's say we both, let's say we just do an ETH. Lord help me. So yeah, let's say we lock up 1 ETH each on chain. Okay. You could imagine that we then have Urbits, right? And you could imagine that we wanted to play a game of rock, paper, scissors with no trust, and then at the end, either one of us could submit the proof to the contract saying that the game really did happen the way that we said it was. Okay, so what we could do is you could pick a nonce, I could pick a nonce, you could commit to with a hash, a signed hash in fact, your move and your nonce. I do the same with my signature and my hash, my move and my nonce, right? We go share that with each other. Now we have both of the ingredients. Now we both reveal our nonces. Okay, so until we've both revealed our nonces, neither of us know if we've won, right? So we're gonna both reveal our nonces. And then whoever the winner is, they can go make a ZK proof that the game was conducted successfully based on our signatures and the hashes we committed to. And now look at that. You can go unlock the money and get the 2 ETH, and the other person loses all their money. So you can imagine building like cute little games out of this, just as examples that involve like basic cryptographic primitives, and then being able to have trustless, verifiable results thereof. Now similarly, now that's just a cute little toy example, but you can imagine composing more complex things, for instance, like one-event voting. You could imagine composing something like a ring signature using a mix of like committed public keys and ZK proofs. Similarly, well, you can imagine building like cute little games like Battleship or anything really that has information hiding. These are all interesting questions. Similarly, there's fun problems that you can solve that aren't just like scalable, trustless computation, but that are rather kind of more in the vein of things like dark pools, where you say want to conduct a bunch of financial transactions on behalf of a bunch of people, but prove that, hey, I actually did something proper at every time step, like I actually matched the orders properly at every timestamp. I mean, Tacen is very involved in this sort of thing. There's many use cases that look a lot like this, and there's a lot of others in games as well that are super obvious, but games are really interesting as an example because gaming is really just simulation. And so if you can get good enough at simulating reality, well, I mean, you can start doing things like ZK physics as well. And so that's where things kind of get silly. I believe I've posted this on Twitter, but we have a grantee that's been working on well, machine learning in Hoon, I believe with our man Neil Davis over here, and one of the guys at Native Planet, Mopfel. And so it's really, really wonderful because the result she's gotten just recently is she's been able to prove MNIST with a, or not prove, I should say, we don't have it running in the ZK VM yet, but she's been able to run MNIST inference properly, so detecting handwriting samples using a machine learning model that she read in just from Clay. So these are the type of use cases where you can take something that you want to do, some task that you want to do that you might want to just prove to someone else, either trustlessly or with information hiding, and then be able to commit to data, et cetera, and then have a trustless proof at the end of the day. Yeah.
Cool. Thank you.
Thanks, Logan. Two-part question. So one is, what kind of performance gains do you get if you were to implement Fibonacci and EVM stuff or whatever?
Yeah, so okay, keep going.
No, go.
Okay.
I'll ask my second question.
Yeah. So with our model, you may be familiar with something like Maiden VM.
Mm-hmm.
It's a well-known Stark example. So we've been building and prototyping just with basic Stark primitives because we think it's a fun way to kind of keep ourselves honest and not get too fancy with the cryptography too fast. Because frankly, like AIR is so restrictive that if you can build something really, really competitive in an AIR context with so many other people building in AIR, it's really, really obvious that you're actually onto something in terms of the model, not just your implementation. And so we're pleased to say that in terms of base columns in our ZK VM, so Maiden has a notion of the base columns that they use to keep track of their stack operations and many of their other operations, and then they kind of have their built-ins columns, which built-ins would correspond pretty directly to jets for us. So for our base columns, at this point, I hesitate to give you the number because it's changed this week, but we're well below where Maiden's at, and we're really, really pleased to say that. And I can tell you concretely, Maiden's far more efficient than any of the ZK EVM solutions.
Well, like longer term, do you expect like an order of magnitude kind of improvement, or?
With the lasso work, maybe.
Okay.
Because as we were discussing, It's not just about instruction set size, it's about decomposability.
Right.
And it's hard to beat binary trees for decomposability.
Okay, and then second part are like, what are the obvious immediate like applications? And in particular, seems like you could build kind of like an Ethereum-based layer 2 with Hoon smart contracting pretty quick on this, like a ZK L2.
Someone could if they wanted to, yes. Yes, that would be a thing that someone could do. Similarly, they could build other application-specific use cases that they wanted to have, say, checked in and validated on a chain of their preference.
Okay, thank you.
Hey, so you mentioned Zorp is going to be running a prover. Say I have free computing power to just burn, right? Is it going to be possible for us to run our own provers? And if so, what amount of computing power are you looking at to run a prover?
Yeah. So right now, we're just using Mac Studios, and they're great for the test. Now, that being said, we're not open sourcing our prover yet. We are going to, and you'll have plenty of use for your computing power, and it'll be obvious. So yeah, you'll see it. Would love for you to use your computing power, build a bunch of proofs. It'll be wonderful.
Good stuff.
Any other questions?
Can you talk about how there's this interesting case where scries and the bound scry namespace makes some guarantees about referential transparency, but it also seems like you can't really feed a fake 12 into this scheme that you're talking about. Can you just address like what happens with that sort of model with
Yeah. So this is a question for us. So with NOC 12, you run up against a question in the start model. Now, in a lookup table-based system like, say, Lasso, or even more conventional lookup table-based systems, this question is not always as important. But in a system built around like a referentially transparent namespace, if you can commit to the namespace out of band in the proof, then you can basically treat queries into the namespace as either something like a Merkle path authentication. Basically, you fall back to that like slow hash verification, or you can treat it like an oracle. And you're really at your leisure to do either one. And frankly, stateless reads into arbitrarily large data are a much better fit for lookups than they are for any easily accessible primitive that you would get in the Stark. But we're in process of more or less evaluating next steps for our prover engine and moving beyond just the naive like Stark approach. So in that regard, while I don't think you're going to get a free lunch with scries because they're not real, I mean, it's not a real instruction. It's a fake instruction that's used for convenience. And as such, it breaks the computing model. So you're not going to get a free lunch with it, but I mean, we have an approach that we could do if we wanted to. Right now with 12, we're just prioritizing other things. And as the prover engine that we have gets more sophisticated, I expect that it'll get a little better. Sure.
Hey, yeah. So given the NOC maximalism, right? What's next in terms of like writing programs that compile to NOC, potentially outside of Hoon?
Yes. That's a great question. So we're building a language, and we're codenaming it Acacia. That is directly inspired by Swift, but won't seek to religiously uphold Swift's entire paradigm and standard library. But yeah, we're building a language that's inspired by Swift that will be, I think, a much more accessible to get started with language that will compile down to NOC than Hoon is. But I do expect it won't be as productive or expressive.
And then a follow-up question. How are you guys planning on distributing this library for testing out your suite?
Yeah. So we'll basically have a testing desk, and we'll distribute that over the LiveNet. We expect that you should probably put it on a moon or something that you are happy to throw away, because we're going to ask that you use a custom binary for it.
Gotcha. Thanks.
Any other questions? No? Let's give it up for Logan, everybody. And that concludes day 2 of Reassembly. Thank you again. Happy hour is being served right now, so please help yourself, get some refreshments, get some food, and we'll see you all back here bright and early tomorrow morning. Thank you.